Hi there. Welcome to Immersion Day webinar. Some of you have come along today are doing our hands-on labs. We'll be covering that just now until around 5 to 2, and then we'll start the Immersion Day proper. So what we'll do just now is, just while people are starting, we'll play a short video that will show you how to log into the event engine details that you should have received, and how to set up some of the prerequisites just for following along on the labs. We'll do this video in a few moments, and then we'll repeat it a few times just before we actually start into the Immersion Day proper. And around about 5 to, we'll do an introduction and introduce everyone, and then go into the presentation. So right now, as I mentioned, I'm just going to play a short 5-minute video that will take you through the steps that you need to log into the event engine. Just before I do that, there is also a chat function available in our GoToMeeting. If you do have any issues with logging in, if you could put the details in there, it will help you out during this initial period. So I'll quickly play that video just now.
Hello all, and welcome to our AWS Immersion Day event. This is a small guide on how to get set up with the prerequisites required for the hands-on lab. As a first step, we need to obtain access to our Sandbox AWS account. By now, you all should have received an email to the email address provided by yourselves while signing up for the event. Please copy and paste the whole link into your browser or click through it as I'm demonstrating. You are now presented with the Terms and Conditions screen with your hash pre-filled in. Please click on the Accept Terms and Login green button. In the next screen, please select the Email One-Time Password option and enter your email address and press Send Passcode button. I am entering my email now. This process has now sent me an one-time passcode to my email address, which I'm copying and pasting in. Now click on the Sign In button. This will now take you to the dashboard of the Event Engine platform, which you will be using for the demo. In this screen, you can see a button called AWS Console. Please click on it. This will bring up a pop-up box, which will then again have a login link, and under the login link section is the Open AWS Console button. Please click on this. This will open up a new tab or a window based on your browser settings, and it will take you to your AWS account where you will be performing the hands-on lab along with our videos. Let's now start setting up our AWS account for the hands-on lab. First, switch to the North Virginia region and type Cloud9 in the search bar and click through to the link. You are now presented with a screen for the Cloud9 service. In here, click the Create Environment button, enter Wild Rights Web App Development as the name. If you want, please provide it as description, else move on to the next step. Leave these settings at default and hit on the next step button. You can review the settings here again and press the Create Environment button now. This will start setting up our Cloud9 IDE environment behind the scenes. The creation of the Cloud9 environment can take a few minutes, so please wait until this process is finished. The process is nearly complete. The Cloud9 IDE has been set up and we are connecting to the environment now. Now you're presented with a screen, and in this screen, you have a little terminal near the bottom of the screen. You can close this one and you can close this one. And if you slightly move this one up, you have the terminal that allows us to communicate with the AWS services. To verify if it's all working fine, do the command AWS space STS space get hyphen caller hyphen identity and press enter. This should bring an output as similar to what's shown on the screen. If this is appearing, you are now all set up and ready to go. If you do have any issues or any questions, feel free to ask those questions via the question console in the GoToWebinar. One of our essays or AWS essays will be able to answer your questions.
Hi there. So that was a short video on how to set up the event engine. As I mentioned, we'll be starting the introduction around 5.2. So if there are any questions just now, if you want to put them in the chat or the questions tab, and we will answer them for you just now. And what we'll do is repeat the video a few more times just for people who are just joining us and make sure that everyone's set up for the hands-on labs when we actually start the process. So what I'll do is I'll just start the video again, and so we'll play it on a loop a few times just to make sure that everyone is set up.
Hello all and welcome to our AWS Immersion Day event. This is a small guide on how to get set up with the prerequisites required for the hands-on lab. As a first step, we need to obtain access to our Sandbox AWS account. By now, you all should have received an email to the email address provided by yourselves while signing up for the event. Please copy and paste the whole link into your browser or click through it as I'm demonstrating. You are now presented with the Terms and Conditions screen with your hash pre-filled in. Please click on the Accept Terms and Login green button. In the next screen, please select the Email One-Time Password option and enter your email address and press Send Passcode button. I am entering my email now. This process has now sent me an one-time passcode to my email address, which I'm copying and pasting in. Now click on the Sign In button. This will now take you to the dashboard of the Event Engine platform, which you will be using for the demo. In this screen, you can see a button called AWS Console. Please click on it. This will bring up a pop-up box, which will then again have a login link, and under the login link section is the Open AWS Console button. Please click on this. This will open up a new tab or a window based on your browser settings, and it will take you to your AWS account where you will be performing the hands-on lab along with our videos. Let's now start setting up our AWS account for the hands-on lab. First, switch to the North Virginia region and type Cloud9 in the search bar and click through to the link. You are now presented with a screen for the Cloud9 service. In here, click the Create Environment button, enter Wild Rights Web App Development as the name. If you want, please provide it as description, else move on to the next step. Leave these settings at default and hit on the next step button. You can review the settings here again and press the Create Environment button now. This will start setting up our Cloud9 IDE environment behind the scenes. The creation of the Cloud9 environment can take a few minutes, so please wait until this process is finished. The process is nearly complete. The Cloud9 IDE has been set up and we are connecting to the environment now. Now you're presented with a screen, and in this screen, you have a little terminal near the bottom of the screen. You can close this one and you can close this one. And if you slightly move this one up, you have the terminal that allows us to communicate with the AWS services. To verify if it's all working fine, do the command AWS space STS space get hyphen caller hyphen identity and press enter. This should bring an output as similar to what's shown on the screen. If this is appearing, you are now all set up and ready to go. If you do have any issues or any questions, feel free to ask those questions via the question console in the GoToWebinar. One of our essays or AWS essays will be able to answer your questions.
Hi there. For those that have just joined us, as I mentioned earlier on, we are aiming to start at around 5:02. This initial period is just to make sure that everyone is set up on the hands-on lab. We'll be doing an introduction around 5:02, and we'll play the intro video on how to actually access the event engine and how to set up the Cloud9. Just one more time, just to make sure that everyone is actually logged in. And if you are having any issues or unclear on any of the steps, please ask a question or enter into the chat in the GoToMeeting, and we'll get that set up for you. So right now, as I mentioned, I'll do the video one more time, and then we'll go into our introduction. Okay.
Hello all, and welcome to our AWS Immersion Day event. This is a small guide on how to get set up with the prerequisites required for the hands-on lab. As a first step, we need to obtain access to our Sandbox AWS account. By now, you all should have received an email to the email address provided by yourselves while signing up for the event. Please copy and paste the whole link into your browser or click through it as I'm demonstrating. You are now presented with the Terms and Conditions screen with your hash pre-filled in. Please click on the Accept Terms and Login green button. In the next screen, please select the Email One-Time Password option and enter your email address and press Send Passcode button. I am entering my email now. This process has now sent me an one-time passcode to my email address, which I'm copying and pasting in. Now click on the Sign In button. This will now take you to the dashboard of the Event Engine platform, which you will be using for the demo. In this screen, you can see a button called AWS Console. Please click on it. This will bring up a pop-up box, which will then again have a login link, and under the login link section is the Open AWS Console button. Please click on this. This will open up a new tab or a window based on your browser settings, and it will take you to your AWS account where you will be performing the hands-on lab along with our videos. Let's now start setting up our AWS account for the hands-on lab. First, switch to the North Virginia region and type Cloud9 in the search bar and click through to the link. You are now presented with a screen for the Cloud9 service. In here, click the Create Environment button, enter Wild Rights Web App Development as the name. If you want, please provide it as description, else move on to the next step. Leave these settings at default and hit on the next step button. You can review the settings here again and press the Create Environment button now. This will start setting up our Cloud9 IDE environment behind the scenes. The creation of the Cloud9 environment can take a few minutes, so please wait until this process is finished. The process is nearly complete. The Cloud9 IDE has been set up and we are connecting to the environment now. Now you're presented with a screen, and in this screen, you have a little terminal near the bottom of the screen. You can close this one and you can close this one. And if you slightly move this one up, you have the terminal that allows us to communicate with the AWS services. To verify if it's all working fine, do the command AWS space STS space get hyphen caller hyphen identity and press enter. This should bring an output as similar to what's shown on the screen. If this is appearing, you are now all set up and ready to go. If you do have any issues or any questions, feel free to ask those questions via the question console in the GoToWebinar. One of our essays or AWS essays will be able to answer your questions.
Thanks, everyone. So now that we've played the video a few times, we'll just shortly be handing over to one of my colleagues, Stephen, to start the introductions, and then we'll go through what we're going to be covering today. If you are still having issues logging in, for those that are working on the hands-on labs, then please let us know in the question tab in the GoToMeeting. We won't immediately be logging in. There is some presentation first, so there is some time for us to help you get set up on that. Okay. And just right now, I will actually hand over to Stephen, and we can start the introductions.
Thanks, John. Hello and welcome, everyone. My name's Stephen Croak from CirrusHQ. Welcome to this Serverless Computing webinar. Why have we chosen Serverless Computing today? I think we see for many organizations that the future of cloud computing is serverless. Organizations that have already adopted serverless are seeing significant increases in agility and cost savings and operational benefits. So what are those benefits? So serverless scales with demand automatically. It significantly reduces server cost, typically 70 to 90% in some cases, because obviously you don't pay for idle. It eliminates server maintenance and frees up your developer resources to take on projects that will directly drive value to the business versus spending that time on maintaining hardware. All organizations take a keen interest in the cost of IT to the business. So with serverless developers, they're only charged for the server space that they're going to use, reducing cost. The code only runs when the back-end functions are needed by the serverless application, and the code automatically scales up as needed. And provisioning is dynamic and precise in real time. And in contrast to that, in a traditional on or off-premise kind of server full architecture, the developers typically have to project in advance how much capacity they're going to need, and then purchase that capacity, whether they end up using it or whether they don't, which is obviously inefficient in cost and on usage. So we want the webinar to introduce or further support what knowledge you've got of serverless already, explaining how you can leverage AWS Serverless Computing to access the benefits I've described and build scalable, high availability applications faster, and how serverless can eliminate the time and expense associated with provisioning and managing servers, including patching and config, administering databases, security updates and patching, etc. So who are CirrusHQ? We are an AWS advanced consultant partner who hold various certifications and accreditations with AWS and Lambda and API Gateway and the service delivery programs and the well-architected programs and in Immersion days, which we're taking part in today. We're 100% AWS focused with 14 years experience behind us, helping customers get to the cloud and migrate. And we do everything from design and implementation to migration and support. And then ongoing after that, doing well-architected reviews of customers' environment to make sure they're designed well. And with us today, we've got our solution architect colleagues from AWS, George Swain and Chris Wood, who will say hello in a minute. And those guys will be helping set up your lab accounts, but also answer any questions you have during the lab sessions and in the Q&A at the end of each lab session. And a big thank you to them for as they provided the AWS accounts to support the hands-on labs. So George, over to you for a quick introduction to yourself and Chris.
Yeah, thanks, Stephen. So good afternoon, everyone. Thank you for joining the Immersion Day today. My name is George Swain, and I'm joined by my colleague, Chris Wood. And we work for AWS on the Partner SA team. And I'm not going to take up too much time today because there's not too much for me to say, other than that we're here to support Cirrus today when it comes to running the Immersion Day. We're obviously very invested in our partners and making sure that we can deliver the right levels of resource and obviously technical knowledge to the wider community through them. So I hope today is really useful for everyone. And like Stephen said, if you've got any questions, then please throw them inside the chat window or post them through the question option, and we will do our best to answer and get to you. But I hope you all enjoy the afternoon.
Thanks, George. So you'll see the agenda for today, 2 labs, each with a Q&A, a break between the 2, and I kind of wrap up at the end where if you've joined today, you'll know that there is a lovely prize up for grabs. So via the random number generator, we'll announce who that is at the end of the session. And in the control panel, you will see that there's an area where you can ask questions during the webinar and also at the end of each session. So hopefully everyone is set up in an AWS account and we can get going. So I'll hand back to my technical colleagues and I'll pick up with you guys at the end. Enjoy the webinar.
Thank you, Stephen. I'm just going to wait 1 more minute for the 2 o'clock mark to start, and we will start our presentation based on from there. Just waiting a couple of minutes more for any late joiners. Right. Hello, everyone. My name is Mahal, and I'm going to be delivering you the first part of today's immersion day. We're going to be covering about serverless and what it means to be serverless, and we're going to, as part of the live demo, video demo, build a serverless web application with authentication inbuilt into it. And the people who are doing the hands-on lab will be following along with our instructions as we go along there. So just to give a bit of an introduction about myself, I am the technical lead at CirrusHQ. I hold 6 of the AWS core certifications, including the Solutions Architect Professional and the DevOps Professional. I'm also TOGAF 9 certified. I'm very much a serverless enthusiast and a DevOps advocate. A lot of the customers and clients I talk with and interact with, and most of my most successful projects all end up being either serverless-based projects or DevOps-based projects. My Twitter ID is on screen. Feel free to follow me. I sometimes give interesting test bits and my take on the AWS services as they get released. Hopefully you find it useful. And let's just dive right into our agenda and what we're gonna do today. So first of all, I'm gonna cover what is serverless, why should you be using serverless, and how can we be using serverless, right? So any kind of topic about serverless, we will be cover any kind of basics or any questions. Feel free to ask them as we go along, and you can raise a hand and and ask these questions. People from AWS are here; they will try and answer your questions as well. And after I finish my presentation about this, we will go into our demo time, and we will be building a serverless web application as part of it. So what is serverless? I know Stephen gave a little bit of a talk about serverless, right? So why, what exactly does it mean? Does serverless mean that there's no servers behind the scenes? Not really. Serverless is an operational construct, right? It basically abstracts the server management away from us as developers and DevOps people. There are servers, but they are being managed by AWS behind the scenes. It is also a way to describe the services, practices, and strategies that enable you to build more agile applications so that you can innovate and respond to change faster without actually having to worry about installing, maintaining, and configuring servers. Let's be honest, servers suck. Every time you need to start setting up a server, start setting up or trying to release a product, if you are serverful, if server based, you need to think about a lot of things. You need to think about provisioning the server, which, to be honest, Amazon's made, AWS has made it quite easy to do. You can click a couple of buttons and get a new server in, but we still have to worry about the operating system, the patches that go into the operating system, basically maintenance. We have to then think about installing the application software required to run our application. We need to then configure scaling policies. We need to then think about how do you load test, performance test, so that you can have accurate scaling policies. You need to do modeling on that basis. All of this stuff, and you still haven't actually done a release yet, right? So it involves a lot of these kind of heavy lifting, and it's called undifferentiated heavy lifting. You don't, you just keep your head down and you need to start doing it. Whereas when we come to serverless, what we actually just worry about is code and the runtime that needs to be installed for running the code. And this what it does is it helps the developers and architects focus on only writing code that serves your customers and serves your purpose, right? You might have come across the terms like infrastructure as a service, platform as a service. Serverless is in its true essence is functions as a service, right? Everything else is abstracted away from you. From a software architecture term, how does a function as a service work? So anytime we talk about functions, there always needs to be an entry point into the function, which is basically the trigger for the function. So how do we trigger something like a function as a service if you don't have any servers or anything like that, or any kind of how do the communication come into to trigger the function? It's called events. This is one of the core concepts of serverless. It's basically a foundational stone in in event-driven architecture. So you always have an event that triggers a function. So event can be anything, right? Event can be absolutely anything. It can be a time-based schedule, a cron task, right? It can be an RPC from a different function, remote procedural call. It can be an API call. You might have come across REST APIs and whatnot in your time as developers. There is a lovely little blog that one of my colleagues, Pete Jackson, he's the business architect for CirrusHQ, has written. It's in our website. Feel free to go and take a look. It kind of gives you an very high level introduction of how to be leveraging serverless architecture and what it means to be serverless as well. So we've talked about what is serverless. So why should you be using serverless? So as I was already mentioning, you don't actually need to worry about the management tasks. There is no provisioning, there is no management involved in here. You don't need to worry about capacity provisioning, the patching, everything's handled by AWS as for the abstracted infrastructure layer, including scaling. Scaling is completely automatic and seamless. You don't even feel the need to wait for some time before a second instance kicks in. If you've been used to auto scaling groups, you would know this by now, where if you have a scaling policy in, you will have to probably wait 3-4 minutes for another instance to kick in, warm up, come into service, be behind the load balancer. None of that here, right? It automatically does what it needs to be behind the scenes. The end user doesn't feel any kind of issue or slowness, and it's amazing. It just scales. By design, it is highly available and secure. It is the core concept of it. It heals itself, it gets provisioned by itself, and it gets destroyed by itself. Because to think about cost optimization, where you pay for validity, you only pay for the amount of time a function is running. You also need to worry about when it gets destroyed, right? So all of this stuff it does behind the scenes, and we don't ever need to even see it or worry about it. What does it actually mean in terms of business value realization? It increases the agility, right? When what stuff took for days or months to do, serverless functions can do it in days, right? One of the nice quotes from Edmunds, who are a car seller and information gathering website and information gathering and showing, they've said that it just took a few days to build a serverless solution based on AWS Lambda, whereas it would have taken them 6 months or else, right? So the next point about it is elasticity, the automatic scaling of it. So financial engines, really good investment advisor providers, they when they got to implement serverless, they were then able to serve 200 to 300 million IP requests in a month, with near zero performance degradation, which is kind of something unheard of in a traditional infrastructure-based system, or data center-based system, or even even if you take AWS EC2 based systems, you still have to then, when there is scaling, as I said, you will have some kind of a performance degradation when it is scaling a little bit. You can have strategies to mitigate that, but being true serverless, it all comes just out of the box. And total cost efficiency, looking back into pay for what you use, you only pay for what you use. Absolutely. With the pricing model what Lambda uses, I will go into a little bit more depth about Lambda in a few minutes. It's coming down in a few of the slides. You're only paying for the amount of time the Lambda runs, and in milliseconds. So it basically takes down your whole cost by a factor or 2 even, right? And I think if I remember correctly, it's 20 cents per million requests. In real world terms, that is quite a lot of cost savings to be had compared to a traditional systems, traditional architecture. When you do a TCO, total cost of ownership, including maintenance, installation, setups, testing, all of that stuff, and when you're just using functions as a service, this is like pennies. So just to dive a little bit deep down on what it actually means, there is an example on screen where we are where we are just calculating about how much it takes, how much it's going to cost to do a Lambda that runs on 128 MB of RAM. A typical execution is 200 milliseconds. Let's take 30 million requests a month come through to the Lambda. It's gonna cost you $11, nearly $12. That's actually cheaper than a pizza. Right? There is actually free tier for Lambda usage. You get 1 million requests free per month, and then you get 400,000 GB seconds of compute time free per month, which is great, right? And and it's a perpetual thing, so it resets every month. So Andy Jassy, the outgoing CEO, has he gone? I don't know. He's basically said if Amazon.com were to be starting today, it would be completely serverless from the ground up. So saying such a big person saying how serverless is important for such a huge organization like Amazon, how would we be doing it? How would anyone be doing it? Architecting to be serverless. To go into that, we need to understand a little bit about what it means, how things compare and the services compare between on-premises and what it takes to become complete pure serverless in it. So on screen, you're seeing a few of the traditional traditional layers in any systems architecture. You have a compute layer, you have database layers, you have storage layers, messaging layers, and analytics layer. So if on the left-hand side is basically your on-premise data center-based infrastructure. So you will have virtual machines on-premise. You can have MySQL on these virtual machines on-premise. You can your data is basically lots of hard disks bundled together, RAIDs, whatnot. On-premise, AWS, on-premise, and Hadoop is basically the analytics service on-premise. From that end of the spectrum, to be completely serverless, there is various amount of services in between. And this is usually a journey. Whenever we go and talk to customers about migration or anything like that, we usually go, there's like 6 R's that we need to talk about, that we will cover, that any migration project handles, but it is always a journey. You start from your data center operations, slowly do a lift and shift into equivalent services on AWS, and then you start leveraging platforms as a service. Comparable services on AWS is like infrastructure as a service. From there, you go to managed platforms as a service items, and from then onwards, you go down to your journey of being true serverless, which is actually cloud native. Serverless is also kind of termed as the true cloud native solution. So just to dive a little bit down on this one, right? So thinking about virtual machines on premise, I'll just go through the compute layer to kind of explain on a little bit more in depth on what it means. Virtual machines on premise to EC2, which is the comparative infrastructure as a service on AWS. Then you go and have something like Elastic Beanstalk, which half of the management is on AWS's end, but half of it is on our end. It actually gives you a platform. So essentially, they will install some kind of a runtime on it, and then you can do deployments on the runtime. Then comes containerization, ECS and EKS, and the serverless versions of ECS and EKS becomes Fargate, where the scaling and the provisioning, everything is managed by AWS. And then it's Lambda's true functions as a service. There is a bit of an overlap between containers and Lambda, which I will go through when we talk about in depth about Lambda in any case. But the core items here is like, if you equate it to real world terms, when you're talking about on-premise data center based architectures, what you're going to have is essentially monoliths. You're going to have these huge systems with lots of functions, with lots of little functionality, all talking to each other, but they are going to be one big system. They are termed as monoliths in our terminology. When you need to be serverless to become architecting to become serverless, you need to be aware of this concept called microservices, because if you think about it, functions as a service, which means you're taking the monolith, which is one big program, down into its functions, splitting it down into its functions that serve a specific requirement, and you take it away and you kind of have them as decoupled entities. And these decoupled entities are called microservices. They interact with each other and they enable agility. You know, if you then think about development times and deployment times, a team can just be worried about one microservice, and you can have hundreds of teams working on hundreds of different microservices, all releasing independently of each other. Whereas if you think about a monolith, where one small change, you will have to get 100 teams to get together to find regression testing, all that stuff before. When you do a deployment, it's a big bang approach, right? So you wouldn't know what is going to work, what's going to break, because you are pushing into this whole big world of one program. So you do not understand the without proper information, you wouldn't be able to understand all the interactions as a little code change will do. Whereas in microservices, and when it's decoupled, you very clearly know what's coming in and what's going out of the system. And you can very clearly have test cases defined for each microservice and do tests for it, and be comfortable in the knowledge that a change into a microservice wouldn't take down the whole system. Whereas in a monolith world, it definitely will if there's something goes wrong. This is where a parallel about bulkhead architecture comes in. So you know in a ship type environment, you have bulkheads. So if there's a leak or something like that, you stop the leak using a bulkhead, and you stop the impact of it in one small area. And it is also a well-architected principle, by the way, on a tangent. And yeah, so coming back to microservices, we've talked about what it is, right? What it is not is also quite important, because sometimes people get distracted by the word micro and services together, and they go, it's defined by a number of lines in a code. It is most definitely not. It is not defined by the number of lines of code. It is not a subroutine. It's not just one function. It is not a CRUD operation, create, read, update, delete operation. It's not an RPC call to a database, for example. It is what it is it needs to solve a problem. As you know, one function or 3, 4 different functions or 5 different functions, how many are different functions together that solve one purpose is a microservice. What it means in a real world scenario, if you take, for example, there is this big web system, a login would probably be a microservice. You know, user registration will be a microservice. They can live independently of each other. They can, you know, you can do an update to user registration, add a new form, you know, add a new form field or something like an address field or something like that, without needing to touch the login functionality. So it needs to solve a function is one of the core fundamental ideas of microservices, right? We're going to be using microservices as we go along. You know, as we go along today, there's going to be microservices in the architecture I'm going to be building as part of my demo. There's going to be microservices in the architecture that John's going to be building as part of his demo. We will see the parallels in each of it. Now we come to a typical architecture. If you remember, one of the first slides where I say, you know, what is serverless, and we talked about how functions are, how it is like a functions as e-servers. We're going to always have an event source that is required to trigger the function. It can be anything, as I mentioned already. It can be a change in a data state. It can be a request to an endpoint. It can be changes to the resource state. When we talk about changes in state, one of the main things that comes into mind is CloudWatch events. CloudWatch events basically capture and inform on any change of state anywhere. So a CloudWatch event, it can be a really good event source for a function. Then there is API calls. An API call is in fact still a change in a, it's a request into an endpoint. And these kind of things can trigger a function. The function, we've kept talking about lambdas. Lambdas are the functions as a service core item, right? I will go in, as I already said, I will go in depth about what lambdas are. For this slide's purpose, we will just talk about what, lambda as a place where you have a platform already built with all the other niceties around it already set up, and some of the compatible languages to be writing for this. Sorry. So for that is Node.js, Python, Java, C#, Go, PowerShell, and Ruby, right? In my experience, as Cirrus, we write a lot of Node.js and Python lambdas most of the times. There's a little bit of Go kicking about somewhere, but Node.js and Python are really, really great in being the true languages of serverless. And so we're coming in through an event source. We've triggered a function. What can a function do? It can literally do anything. It's up to your imagination. It can talk to any other AWS services. It can talk to a third-party item. It can talk to a third-party API. It can talk to actually another. It can actually then trigger another Lambda function in a chain. The implications and the implementation is limited only by your imagination. That's great, isn't it? So one of the limitations when we're talking about the advantages of of Lambdas, one of the limitations we need to be aware very much so is the 15-minute execution limit for a Lambda. It's not there for anything that's container based. So that is one of the core difference between a container based environment and a Lambda based environment. The lines are a bit fuzzy right now. I will go, I'll explain why, but the 15-minute limit is a key limitation in Lambdas. Your execution can't be above 15 minutes, and you always need to kind of have, if there is a situation where that happens, then you need to be aware that you will need to have steps to resolve that kind of a situation. So we already covered what these event source functions and services are. Services, key services that come into my mind are Dynamo and S3. So anyways, now diving deep into Lambda, what is Lambda behind the scenes? What is it? It is actually containers on an EC2 backbone, limited by the amount of configuration that you can do around it. It basically lets you run code without provisioning or managing servers. The functions that you're writing can be packaged and uploaded either via the console directly or via CloudFormation or any other methods that's applicable in AWS. It's the true function as a service. When we talked about setting up servers, the only kind of major items that you need to worry about doing in Lambda is choose the runtime. You would probably have chosen it when you think about what language you need to write, and there is a set of languages and runtimes that is compatible with Lambda. You then need to think about the size the Lambda needs to run, equivalent to EC2 types, where you need to worry about T2 micros or T2 nanos or M5 larges and stuff. Here we talk about in terms of CPU and memory. So I want to give 2 CPUs and 128 memory or something like that. We can do that in Lambda, right? And then the permissions. So this permissions is a core setup that needs to be done on any of the AWS services anywhere, because security is a cornerstone in any architecture. It should be shifted left in the sense that you think about security as you write software and as you build software. And permissions are one of the key aspects. And there are actually 2 types of permissions that we need to set up to get Lambda running as expected. Just to loop back into the 15-minute time limit I was talking about in my earlier slide. And when I said the lines are now fuzzy, right? Technically, Lambda is containers behind the scene on an EC2 backbone. What Amazon very recently in the last couple of months released is the ability to upload a whole container as a Lambda, right? So so that's actually groundbreaking in a sense that you can have containers, and people who are used to writing Docker and whatnot, you can containerize what you're writing and actually upload them and run them as a Lambda. The only limit here is the 15-minute execution limit. So that is where the line gets a little bit fuzzy right now in any case. So the next step I'm going to talk about is the Lambda permission models, which gives you fine-grained security controls on both execution and invocation. There is 2 parts to a Lambda permission model: execution-based permissions and invocation-based permissions. Execution means what the Lambda can talk to. So for example, I'm a Lambda, right? I want to write to dynamodb table. That's execution permissions. That's given by assigning an IAM role into my Lambda, into me, right? And which says I'm allowed to write to a dynamodb table. Whereas then there is the invocation policy, which is a resource-based policy, which basically says the event needs to come into me, right? So let's say somebody is going to call me. We need to give that somebody permission to call me. For example, we're talking about me being a Lambda, right? Let's say John's the API gateway. He's basically tapping me on my shoulder. We need to give John permission to tap me. That's resource policy. So that's function policies, right? So we are basically then giving, for example, telling I am allowed to be invoked by John. In a sense, so as a Lambda, I'm allowed to be invoked by the API gateway. So that's what that means. It is one of the key factors, and we will actually be setting both of those things up when we are going through the demo. We will, because we're going to be running a Lambda and even needs to come in, we will set those two things up, and you guys can obviously follow it as we go along. So what's actually inside a Lambda function? What is the structure of a Lambda function? You're going to have a handler, an event object, and a context object. If you go back a couple of slides, we were talking about the architecture of serverless, right? So you're going to have an event triggering a Lambda, and it can write something. So event basically, and any event will give an event object that comes into a Lambda. So if an API gateway is sending a request in, there is an API gateway event object that comes in. If CloudWatch event sending an event in, there is a different structure for a CloudWatch event that's coming into a Lambda. So everything is given as a JSON structure and becomes an object and comes into the Lambda as such. Then you have the handler function, which is where your core code is going to live in. And you can have multiple little functions inside the Lambda. It's how you architect a function in any case, or a microservice in any case. And under context object, the context object is basically any other extra information like request ID, the log group, etc., that can be used by the Lambda. So on screen, on the black box, the first two lines, as you can see, are outside of the Lambda handler function. It's above it. So what does that actually mean? They are global variables. So you can, inside a Lambda function, you can declare those things as a global variable and can be used by any of the sub-functions or the subroutines or anything like that that's going on inside the Lambda itself. So that is one of the key, that is also a key concept in writing a Lambda function, and it is quite important. So how do we use Lambdas? When we say use Lambdas, we need to be able to write Lambda, we need to be able to monitor Lambda, and we need to be able to kind of manage the Lambda and any of the architecture that Lambda is going to be talking to. So authoring Lambda functions, you can use any of your own IDEs. Visual Studio is what I use personally. I know people who use Eclipse, brackets, whatnot. And for today's purpose, everybody here, we are all kind of using Cloud9 in any case, which is like a cloud version of Visual Studio in a way, in a tangent way. It allows you to write code, edit code, whatnot, and then deploy code, because directly from the console itself, as you already saw during our introduction video when we were setting these things up, you're actually having a little terminal below with the permissions already set up, and that you can start doing commands in there to deploy what you write in there. Monitoring and logging, we have CloudWatch metrics and monitoring for here, and then there is the built-in logs. CloudWatch logs is used in here, and X-ray is used for deep tracing and stuff. So, and programming model is basically, we already talked about Python, Node.js, etc. Lambda execution models, we have synchronous execution, asynchronous execution, pole-based execution, which goes down to how events are coming. And synchronous is basically things like a push event where you're going to have a request coming through an API gateway. An asynchronous event is basically things like if you put an object into an S3 bucket, that can actually trigger an event, things like CloudWatch events, for example. Pole-based is basically SQS queues or dynamodb, and the Lambda can poll these things and get events and do what it needs. I just touched about dynamodb, right? DynamoDB is basically a key value document database, and it is the data store for serverless. It can handle 10 trillion requests, more than 10 trillion requests per day. It can support more than 20 million requests per second. In terms of scale, that is actually mind-blowing. It is the data store built for serverless applications. It is the cloud native data store for serverless. It can be encrypted at rest. It is also enterprise ready. It is technically a NoSQL database, but actually, is it NoSQL though, right? Because when you go and talk to customers where we talk about NoSQL items and NoSQL data structures and things like that, people kind of get a little bit more scared is not the right way. They get a bit more defense. It's not what they're used to. It's a mind shift change. What Amazon very recently done is release PartiQL compatibility, which then means that we have introduced SQL in a NoSQL world. It has you can run SQL queries against DynamoDB now, and there is a NoSQL workbench, which is basically like a GUI modeling and system GUI for DynamoDB, kind of equal to MySQL workbench really. So it's NoSQL workbench. And API gateway, it's actually kind of then gives you a little unified interface to coming into it. DDoS protection is inbuilt into it. It can authenticate and authorize requests. We will be actually using it. I'll be talking more about it in detail during my little demo. And this is a little kind of graphic about all the different things an API gateway can do. For example, it can have an authorization, it can talk to a Lambda, EC2, any other managed services like Dynamo. It can directly write to Dynamo, if you believe it or not, right? You don't need to actually have a Lambda between an API gateway and to writing a Dynamo. You can directly write to Dynamo. It kind of has the functionality built in it, and it can talk to publicly accessible third-party endpoints as well. One of the another key items we're going to be using in today's demo is called Cognito, which is basically a user management service. It's like a directory service where you can have users sign in and create profiles and things like that. Use it to create profiles, and what it gives you is a flow to kind of be able to log in and securely, and it can store and be synced across devices and stuff. So it's actually a really great service. So enough of me talking about all the good stuff about serverless. Let's get our hands dirty and into the demo time. What we're going to be doing today is build a little web application called the Wild Rights application. What we're gonna do, the functionality is we're gonna request unicorn rights from the Wild Rights fleet. You can see the parallel here, and it's gonna be built as a RESTful web service. We will then be able to provide a service for the user to be able to register and able to log in before requesting the rights. Just think about what are the services, why I talked about certain services before. They are all going to be used here, and this is what we're going to be building. So we're going to have Cognito as our authentication layer, an API gateway, which then talks to a Lambda, which then talks to the DynamoDB table. We're going to use another service called AWS Amplify, which I will go through in the demo in any case. It's quite cool, to be honest, and let's get started. So for people who are following on, or people who are looking at it, this link here is basically where we are going to follow on. There are instructions in this link here. I will post this link in our channel as well, so that people, if you want, you can click through and follow it on as you go along as well. There are instructions in it as well. So hey ho, now it's hands-on demo time. Before that, I'm just going to post that link into the chat window, in the questions window, for everybody to see, I believe. So everybody should be now looking at it. And hey, so I'm gonna wait for Lauren to start the presentation. Lauren? Hello guys, we've just come in from the presentation. I'm going to start the demo right now. And if you remember, the scenario that we are doing today is called the Wild Rights application. We're going to start building it. It's a simple web application. and it enables user to hail rights in a unicorn. Fun. And it's going to be able to facilitate users to be able to register into the application and come and it's going to hook up into a REST API behind the scenes. We're going to build, as was shown in the previous screens, like an AWS Amplify is going to be used to build the static part of the application. There's going to be an API gateway involved. There's going to be cognito involved for user authentication pieces, and then a little Lambda behind the scenes, and which talks to a dynamodb interface. So let's start with this, and as you can see in the screen, let's start with the static web hosting part of it first, which is going to be the S3 based JavaScript application. So we have, if you remember, we have set up our Cloud9 IDE enrollment as preparation for the hands-on lab, and we're going to be using that quite a lot. And for that purpose, and I'm using North Virginia region for this for the demo itself, whereas you guys would have been given what region you need to be using while we are setting up your initial access to the demo environment. And Amplify is the service where you can write the JavaScript code, and it will also hook up into code commit, which is our GitHub type repository where you store the code in a version controlled manner. And let's start using this repository right now, right? So first of all, we're going to create the Git repository. For this matter of purpose, I'm not going to be typing everything in. So I'm going to be copying and pasting certain things into the window. And first of all, creating a repo, so yeah, the repo has been created. So if we kind of go back into our console and see in code commit, the repository would have been created. There you go. Wild Rights application has been created as a repository in code commit, and we're gonna clone the workshop code from GitHub into this one, into the Cloud9 environment. Yep, it's done. So doing a little bit of an ls, we have the directory in here. So see the AWS Serverless Web App Workshop. Going in here, and we're gonna install something called git subtree so that we can split it out for our own purposes and commit it back into code commit for us to be using it. Because as you just saw, we got an open source version of it from GitHub. Now we're gonna split it into a subtree and use it inside code commit. Just making sure subtree is installed, and then we will be on our way. So yeah, we have created a branch called Wild Rights View and splitting it into its own tree. And now done. Initializing a little Git in there. Now we are actually adding our code commit as a origin to this, remote origin to this. And now pushing the origin back into the master in code commit. And cleaning it up. Done. So we have now set up our repository for where we're going to be using this. So if you can see, last modified is just now. If I go into the repository itself, you can see objects in here that we're going to be using. It's here. It's using view.js as the framework, and we'll be using amplify to create the object, create the options. So the next step is basically deploying the site in the AWS Amplify console, right? So we're gonna go into the Amplify console and start doing what we need to do from that point onwards. Let's just get started. Host your own web app. We're gonna use code commit for this. We just have one update in here, so selecting the branch master, that's fine. And now we need to set up some of our build settings. Creating a new enrollment for it. So probably just use prod and give it a name called prod. We don't have any service roles. If you remember, I was telling during the presentation, roles and permissions are critical whenever we're setting up any type of application in Amazon. So these roles and permissions need to usually set these things up first, right? So we're going to create a little new role for this purpose, and then creating go from there. Okay, roles, create role. We're gonna have amplify. We're gonna create a role for amplify. Permissions. It will give it some permissions. Next. We're gonna give it a name called wild rights backend role. Wild rights backend role. Create role. And refresh this one. Yay! We got the new role in here. So and basically next, and we will start having the backend stuff deploy, save and deploy. As easy as that. First build is in progress, so we just need to wait for it to finish. You can see that by default there's a little CI/CD actually set up, which is cool. In DevOps, well, this is like the cornerstone for any any great development activities and teams, DevOps teams. We usually CI/CD setup is a cornerstone for it, so we're going to be using that. And by out of the box, Amplify is giving that for you guys, setting it up for you guys. So you can see it's provisioning, building, deploying, and verifying as part of it. So it's the build's currently going on. if you just want to look at what's happening in the build, let's try through that one. Yay. Now we are back and it's deployed and it's verifying if it deployed properly. Wait for a few minutes. Hey, there we go. So if we click through that link, we have our virtual wild rights application on here. Giddy up. Hey. So just a recap of what we've done here in any case. So we've kind of set up a little repository in code commit, cloned from one of the open source repositories that which hosts the code for this particular exercise. Created a little fork and subtree and put it up onto our code commit repository. Hooked up AWS Amplify console. It set us up with a little CI/CD, and it basically has provisioned, built, and deployed our little S3 based JavaScript application. So let's just do a little bit of a change to this application, right, and see if that actually gets deployed properly. So what shall we change? Shall we just change the title? We should probably just change the title. So to do that, I'm going back into my Cloud 9 environment and going into my public folder in here. So there's this index.html. So let me change the index.html. I use Vim. So what shall we change? So there is a little title wild rights, right? So let's change the wild rights title. The capital W and just call it Immersion Day. And save and quit. And let's do a little git push. Just giving a commit message, say updated title, So git push. Done. And if we go back into our Amplify console, you can see that the push has already triggered a new provision, and it will basically build and deploy the app. And we can also just verify our code commit repository that it has gone through into it. So if you look at the commits, updated title, just not by me. It's coming back into my Amplify console again. It's building it. We have a little screenshot as well. Great, that's built, deployed, and it's actually verifying things now. So if we refresh this one, we should have our title changed. Hey, look, Wild Rides Immersion Day. So we have changed the title in a very simple manner. Do a change, commit the code, and it goes live. Great. So going on to our next part of the system, where we're going to do user management. If you remember the spec, we now have like a static website in here. We now need to make it dynamic, making it dynamic. So we have a user management. We need to get people able to be registering into the application. You're going to be using Cognito as our authentication user pool, and we're going to be using the Amplify CLI to create the user pool and get the functionality up and running. So just to give an idea of the overview, what we're going to be doing architecturally, right? So the user, whenever they come in, they will authenticate their username password against Cognito, and they will be given a JWT, which will then be used to identify the request they're going to be using it in. And let's start the implementation of this. So first of all, what we need to do is to install the AWS Amplify CLI, and we're going to be using, because we're using our Cloud9 editor, we're going to be installing it in there. So we're just going to use npm install, and npm is the node package manager. We're going to use that to install globally the package Amplify and the CLI for it. Great, that's installed now. So the next step is to kind of ensure we have a default profile of some sort set up in our Cloud9 machine. So we're just going to do that. So we've now finished installing the Amplify CLI. So we just then configure a little bit of the AWS roles and stuff. So we kind of gave it a little bit of a profile default in here. And the next step is actually initializing the Amplify CLI in here. So I'm just doing an amplify init command here, which then started installing it, gave it a few, left it at the defaults, and now we have a finished and set up Amplify CLI here. Just to verify if it's all working, we just do amplify version. It should show us what the version is. Fingers crossed. Yay, there we go. 4.46.1 is what we have. So we have a working Amplify CLI. Just to kind of recap what Amplify CLI is, it's like a unified toolchain that helps us create, integrate, and manage AWS cloud services from the app. And it is kind of designed to work with JavaScript library, and it out of the box gives you plugins like the authentication, what we will be using, and it helps us. It also gives us the SDK for mobile, iOS, and Android application development, right? So now we're going on to the next fun bit. We're actually going to set up a cognito user pool. So what we're going to do is, first of all, add a authentication module to this. So which we do by amplify add auth, as simple as that. And it adds it. Username. And no, I think I don't want any other advanced settings. It's just a username is fine. And it starts doing its own thing. Hey, we've got that one added in. So now we need to kind of do a commit and git add dot git commit saying configure cognito. I can type right. -m. If you remember, git commit -m means a message. If you do without m, it basically thinks it's committing a file. So that was the mistake there. But hey, anyways, git commit -m, configure cognito. There it is. And we do a little git push again. And if you remember what happens, this will essentially trigger a CI/CD pipeline to pick the change up and start a new provisioning, as you see. Now that will go through the actions. So we have added a authentication module to our application. We have pushed the change into it, and we're using the Amplify CLI and the Amplify frameworks to help us get that
where we need to be, right? While it's finishing its thing, and if we go back and look at our app client, we are now setting up our cognito stuff. While the deployment is happening, we can now go and look at cognito. And if you go and look at our user pools, this is like a place where you are where all your users are basically stored in a way. So I think we probably need to wait until the deployment's finished for this to start appearing here. So the build is completed and we are now in verification state, and it's done verifying. So let's see if our user pool has appeared. Yay, our user pool has now appeared. So if I'm just gonna go a very quick spin through the user pool, you can see there's no users in here. The required attributes is just an email. There is a little bit of a password characteristic, password characteristics in here. Requirements for there's no password policies in there, but just a little minimum password length is in there, and that's all set up. So let's basically start configuring the user pool in this aspect. Right, so first of all, we needed to go and look at the app client settings, because it is actually an app that's hooking up to this one. So there is a web client and an app client in here. You can see that. Right, so we can see how our user pool for WildRide is now configured. This is the web app client for this one, the specific one. You can see the token expiring is 30 days and all good stuff from that aspect, and it's just, yeah, it's all configured already for you guys. And if I go back and look at our code itself, and if I go into this file, so just going into the source and looking at that, there is a file that exists in there. So if I'm doing a cat for that file, this is the file that's actually configured for us to be able to use this particular user pool in a way. So that's what's been, this is the configuration file that is being used for this particular aspect. So how are we going to start creating a user, right? So instead of keep writing browser-based code for doing it, and managing the registration, the workflow, the verification process, we have now Amplify that helps us do this via the authentication UI component. So it's kind of gives us a basic login logout functionality, and it can also let us actually register into this application. So first of all, we need to actually go into the auth part of it, and it will start showing up. And you can actually create a new account from here, as you can see. So I'm just going to create myself an account called Muthal, give a random password, and I'm going to give my email address. If you remember in the previous step, we actually have a requirement of having an email address in when you're registering for the application. Just going to give a number as well. If I actually remember my number. Okay, password policy. If you remember, that was, I have to have at least 8 characters in there. Hey, I'm gonna save it just the next time I don't need to type it in. So it's gonna ask me for a confirmation code, because it's actually sent me a little confirmation code in via email. So I'm gonna copy that and paste it in here. So I believe as of now, my user has been activated. Hey, who's logged in? This is my authentication token. It's the JWT token, so you would probably need it. There's no API to invoke the URL, so we will do that as the next step. We need to start building the backend and the API gateway for hooking things up in here. So we will need until that aspect, we will need this token in. Oh no. Just refresh this page. Yeah, got the token again. Great. Copying it and and I'm just keeping a note of it in a notepad scenario. I mean, I don't need to because we can always come back in, and if you load this page, it's gonna supply it, but hey ho. So just having it in there. Right, so just to recap what we've done, we've installed AWS Amplify CLI as part of our application source code repository. It's a very simple thing by saying add authentication module, but out of the box, it's actually giving us the framework and the pages and things that's required to create and manage a user registration flow. And you could see how easy it was. We managed to do it in like 15-20 minutes actually. And we now have a working registration page, which you saw me register into the application using my email address and stuff. And hey, that's great, right? So let's now go on to the next part of things, which is actually building the serverless backend, the fun part, where we are going to build the Lambda out. We're going to build the dynamodb to store the data, persist the data in there. So if you remember what I was telling you in the presentation, Lambda is the function as a service thing where you can deploy functions written in various different languages. For this particular demo's purpose, we're going to be using Node.js, and in Node.js, the code's already available as part of the application. So I'm not going to sit and write Node.js code fully, but actually copy and paste the Node.js code, and we can see it actually work. DynamoDB is our NoSQL data store where we're going to create a new DynamoDB table and configure it as part of the application. And if you remember again, as I keep mentioning, IAM roles and permissions, which is like the cornerstone of anything in AWS. You need to give relevant services relevant permissions to be able to access other services and other aspects of the product as such. So going on to a little overview of what we're going to build as the backend part of things. As a user, we're going to come in, we're going to use we're going to send a request into the Lambda and asking for a pickup location. It persists the right details in the DynamoDB, and it returns the value with whatever unicorns available back to the user. So that's that's a very high level idea of what we're going to be doing right now. Going back into DynamoDB, so let's go and configure a little DynamoDB for our aspects, right? So going into Dynamo console, just cleaning up the other notifications. Let's create a table. So let's create a table called rides and a partition key called ride ID. Partition key is in relational vault, we have something called a primary key, right? Whereas with an equivalent thing in a NoSQL world is actually partition key. So that's what we're doing. So it's almost like a unique identifier, and it's just we're just gonna call it a string. We can optionally add a sort key, which enables us to sort things up and down, group things and sort things up and down. But we're not gonna add that one for here. We're just gonna have one primary partition key in here, just leaving it as default settings, provision capacity of 5.5, and yeah, so just let's start creating the DynamoDB table. Yay, the table's created. So you can see there is no items in here, it's just a ride ID in here, so all good. And from that aspect, you can see a little CloudWatch metric console. We haven't started using it, so there is nothing there to populate it. So the next thing we're going to do is start configuring the IAM roles that's required for our Lambda. So going into roles, I'm going to create a role for our Lambda execution. So I'm going to call that role like so we need to say which service we're going to use the role for, which is the Lambda. If you remember the last time we did this, we did it one for Amplify. So we're not doing it for the Lambda. We're just going to create a little policy in a sense, but there is there would be a managed policy, I believe, Lambda basic execution role. So what it does is kind of gives us, gives access to CloudWatch logs to essentially enable Lambda to write its own metrics and logs back into CloudWatch logs so that we can then go and monitor or analyze or whatever we need to do with that, right? So giving tags, maybe I'll give it a tag. So I'm going to call it purpose immersion day. Let's review. Give a role name for this. I'm gonna give it a little, I'm gonna just call it wild rides Lambda as the role name, and create role. So wild rides Lambda here, there it is. So we now, if you look at it here, we actually just have permissions for CloudWatch logs here. So we also need another set of permissions for the Lambda to be able to write into dynamodb. So what you do, add a policy. So we can either add a managed policy or actually just add an inline policy to go in there. So I'm just going to add an inline policy for this aspect. If you're amazing at JSON, you can write the JSON out here on your own. But if you're like me, easier to point and pick things, Visual Editor is great for that purpose. So dynamodb actions. What are we gonna try and do? We probably need a little bit of a write and get actions, right? So we're gonna have a put item inside permission, and we might also potentially need get item. Just in case, we can give that permission in here. Where's gets in read, I believe, get item, and a little bit of a list permission as well, so just to list the tables available. I'm just gonna say it's okay for all resources in here. Any dynamodb in here, we can very much specify down to a very granular level of permission allocations in here. I know if you're doing it in an enterprise level for the demo purpose, I'm just giving it for everything. But if you're working in an enterprise level or in a secure environment, it is always recommended to have least privilege as possible. So which is basically reducing the permissions to very specific items and resources in essence, right? So review the policy. Give Dynamo write access. And let's create the policy for that. Let's do that. And we now have that policy added into that. So great. So the next step is actually configuring the Lambda itself, right? So doing the Lambda, going to the Lambda console now. Create a function, author from scratch, great. So let's call the function request a unicorn. As I said, we're gonna write it in Node, so we'll leave it as Node. I'm gonna probably use Node 12 if it is not, it's not available. Node 14 is fine. Permissions, we need to assign the role we just created. So use an existing role. If you come back, while writes Lambda, that's what we're gonna use, and basically then create the function. Now in here, we just need to give it a bit of code in here. So I have my code in place already. I'm just copying and pasting it. So if you look at the code very quickly, some random bytes requiring AWS SDK, initializing the document, DynamoDB client. We are calling a fleet of, setting a fleet of unicorns. Shadowfax. I love Shadowfax. Any Lord of the Rings fan in the house, but hey, Shadowfax. Exports handler, which is like the main kind of function handler in here, and we have started putting things back in here, so we can request writes in. So we then need to do a deploy of it so that the changes have been deployed. So that's great. So we now have a little thing in here. So first of all, the next step we need to do is, I usually say this for everything, whenever you're writing a Lambda, it's always best to test it as you write it. So we're gonna create a little test case for here. And our test case is gonna be a little test event that we need to create. We are mocking API gateway request in a way. So we're gonna have a little API gateway request mock thing going in. So this is how how it's going to say it's a path to start HTTP. This is how an API gateway requests will come into a Lambda. If you go back to my presentation, if you remember, I was saying events are required to trigger a Lambda. Events can be anything. Events can be an API gateway request. Events can be a resource state change for your CloudWatch event. Each one of these events have a different structure. And this is the structure for an API gateway based event. And this is what we have now in here as part of the test case scenario. So just a random thing in here, random names, the username and stuff like that. It's a mock use case. You don't need to give actual usernames and stuff like that. So I'm going to give it a name called test and create. So we now have a test event in here. Let's just use that to test. Hey, 201, it's actually created a little write ID, request ID from in here. So that's actually working as expected. Awesome. If you, any HTTP people around here, 201 is the response code for created when you're in a REST API type world, right? So 200 is success, 201 is created, 403 is forbidden, 404 is not found. It's good to keep on top of those response code in memory, right? So usually it works whenever I'm doing web systems. It's always in my head. So great. So the next, just a little recap what we've done now. We've actually started to build the backend of the system. We have a little Lambda that's actually writing to a dynamodb table with the relevant permissions associated to it. So that's great. So we've built that one now. So the next step is actually building the REST API interface that's coming in and triggering the Lambda for what it needs to be. Okay. So now that we've finished setting up the Lambda backend, our next step is to actually set up the event that fires the Lambda. In this case, we're going to try and get an API gateway call in. As I was talking about, when we were testing the Lambda, we tried with the mock API event when we were testing it. So kind of gonna do the same thing. And then if you can see the screen, basically from the web browser, you're going to get an API call that's coming through into the API gateway, which will then proxy it onto the Lambda, and then which will go and store it in the dynamodb table and return back its response to our front end actually. So great, let's get stuck in. So first of all, what we're going to do is create a REST API. There is a lot of different API gateways available. So some of the things are HTTP API, which is a very lightweight version of the REST API, where only like a Lambda and a HTTP backend is supported. Then there is a WebSocket API gateway, which is like when you need to have a persistent connection to the backend, you use it. It's useful for things like chat backends and real-time dashboards and things like that. So that's quite useful in that aspect. So what we're gonna do is a REST API, which is like a fully featured REST API gateway, which can do quite a lot of things, and manage API capabilities and control the requests and do response transformation, etc., and all of that good stuff. So let's go ahead and get started. So hit build from the dashboard, as you can see in my screen. Right, let's start creating the new API. So what we have in your screen, we just need to give a little name to it. So we'll just name it wild rights. So there is like 3 endpoint types, which is regional, edge optimized, and private. So we're gonna choose regional for this one, just to keep it simple. Regionals are just deployed in a current region. It's slightly cheaper, whereas edge optimized is behind a CloudFront API. A private API is only accessible from within a VPC and stuff, so it's not available outside of the world, to the outside world. So we just keep it to regional API gateway for now, for this purpose, the demo's purpose. And we just hit the button, create API. So that's the API gateway created actually. Great, really fast, isn't it? So now the API gateway is an empty API gateway. There is nothing mapped onto it. What we now need to is map a path onto the API gateway, so that when we are coming to request it, we will request the path in. We're gonna use a post request type, not a get one, because we're gonna try and we are actually requesting a unicorn by the use case scenario. So we're gonna go in and put our location in the dynamodb table, which is the post request. It's not, we're not getting data from Dynamo. We're basically saying, I am here, give me a unicorn. So that's why we're gonna use post. And I'm gonna hit create method. So the structure is like, you have a root, you have an API gateway with nothing on it. Then you have resources and you have methods under a resource. Resource is your first level path in essence. So we're gonna create a little resource. So I'm gonna say, first of all, create resource. So I'm gonna create a resource. Gonna name it I'm just gonna call it write. So write. So with the path will be /write, as you can see. I'm just gonna enable the API gateway course. Course is, it is cross origin requests. So I'm just enabling that, and I'm hitting create resource. So that's created. And as mentioned, I'm also going to create a method to allow post requests underneath it. So doing that now, hit post. Done. So now we've done that. We have a post method set up, but it needs to talk to a Lambda. So we're going to use the Lambda function. And then we're going to enable the use Lambda proxy integration, which is basically, as the little prompt says, it will be proxied over. The event will be proxied over. So all the request details will be passed on to the Lambda. If you remember, if you look back and remember when we were doing a test on our Lambda function, we were creating a test event which contained a lot of headers and things like that, which, that is the detail that gets passed in when we check this box, and the whole request body that's coming inside the API gateway gets passed on to the Lambda, so that the Lambda then can do whatever it needs to do from that point. So Lambda region is North Virginia, US East 1, where I am having it. So, and if I remember right, what's my Lambda name? I'm just going to go into my console, back into my Lambdas, just to remind myself of the name, and request unicorn to avoid typos. Request unicorn and hit save. Yes, please. So that's given it the permissions it needs. The dialog that just came up, it was asking me, I'm going to give permissions to the Lambda to be invoked by the API gateway. If you remember, there are like two types of permissions. One is the role associated with the Lambda, which gives the Lambda permissions to talk to AWS resources or use any of the AWS resources. Whereas there's another one, resource policy, function resource policy, where any other services like API gateway, you allow them to invoke the function as such. So this is the second part. This is the function resource policy. When we're doing it behind the scenes, API gateway just automatically ensures that it gets the permissions when you click OK in the dialog box, right? So we now have that, and now we need to just hook up the method request, the authentication part. We've created a little cognito user pool to ensure we have users into it. So we need to connect that and here. So at this moment, there's nothing in here. So we need to, first of all, create an authorizer, which you do by going into the authorizers bit and create new authorizer. Just give it a name. Let's give it a name. What shall we call it? Just call it wild rights again. It is a cognito type authorizer, and the drop down basically shows us our user pool, and the token source is basically authorization, and we don't need to do a token validation, so that's all good. Hit the create button, that actually creates it. So now that the authorizer has been created, let's basically test the authorizer. Hitting test. it's asking us for a token. So if you remember the morning when we were looking at the Amplify website, that it was generating a token. I'm just going to use that one. And hit test. Hey, that works. So it's actually validated my cognito user. As you know, I'm Mohib.1, you know, I signed up earlier, and you can see that's working as expected. So great. So now the next step is actually to connect the authorizer, the customer authorizer, with our post method. So if you go in here and into a method request, open up the authorization, you can now actually see our new cognito user pool authorizer appearing. If it doesn't appear, just to refresh your page and hit the connect button, it will start to appear. Good to know. So, and then we basically say okay for that. That saves it. And great. Now on to deploying the API gateway. What we've now done is almost like a scratchpad kind of an area. We are creating our API gateway. We haven't yet deployed it to live kind of a system. So we now do the deploy API action, which is essentially, as the name says, there is no stage at this point of time. Stage is like an area where you can have different versions of the API deployed in different areas, because you can have different integrations coming into your API gateway. So we're just going to say a new stage. We're just going to call it, let's say, prod, and yeah, hit the deploy button, and that's actually created as a stage and actually created as the right option and everything. And now we have an invoke URL for this. So let's take the invoke URL. If you click through it, that's what will happen. You just need to first of all copy it. We now need to go in and edit our code base. Just gonna clear the screen here. Right, under the Wildroids thing in our Cloud9 environment, under source, I can just go from cdsrc, and in here, if you look, there's a bunch of files, and in here what we need is the config.js, and you can see a little invoke URL which is actually empty. So we will need to put our new URL that we copied from our API gateway in here, save it, commit our change like we've done a few times now. Git, first of all, add it, git add dot, git commit -m, which is for a message, adding API J URL, and push. And it's pushed to the master, and we will be fun to see our CI/CD has kicked off again. Great. We just now sit back, relax, and you will get our code live into our application. While we are waiting, I was going to show you guys a little bit about the monitoring aspect of the Lambda itself. If you look at the Lambda thing in the console, you can see a monitor tab in here. And under the tab, you can see metrics, logs, and traces. Metrics is essentially how many invocations has been done, duration of the invocations, and their error count and success rate and things like that. The logs are more interesting because it actually captures everything that's happening in the Lambda. Anything that the Lambda is emitting to be written into a log file goes here, and you can easily go to the log stream. Just clicking through that link takes you to the log stream that is being recorded, and you can see one of the most recent logs in there, which we were, if you remember, I was testing the API gateway authorizer, which was just like now done. I think it's yeah. So you can see that's info received event, etc., and it's actually authorized that. So hey ho, coming back. You just need to wait for a little bit before our amplify things built and finished. Well, just while we are waiting, I was going to give you a little bit of a summary and a recap of everything that's been happening since we started the demo. We started it by using the Amplify framework to write a little S3 hosted JavaScript-based application, our while rights application essentially, and we saw how easily we can connect an cognito user pool into it, and based on the user pool, how it was so easy to build a whole user registration workflow. It was as simple as adding an extension to our code base and going from there onwards. And we ended up signing up. You saw me sign up for an account from there, and after that point, we started building the backend of it, the serverless backend of it. We created a Lambda, associated an IAM role with it, giving it permissions to write to a dynamodb table. And then we have now actually created a REST API, which is will be the event trigger that's coming into the function. And we saw how when we are doing it, the API gateway asks you to kind of approve that it can give itself and give the Lambda permissions to be invoked by the API gateway, which then automatically happened. We tested it, and then we kind of deployed the API gateway, and now we have got an API gateway URL, which we have now put into our code base, into the config.js, which then now actually has connected our front end and the back end. If you take a step back, if we in the presentation I was talking about microservices, right? This is in essence is a microservice, and the front end is decoupled from the back end. So even if the back end was unavailable for a few minutes, the whole system won't go down. The same thing about if the front end wasn't available for a few minutes, if there are other things connecting to the back end as a microservice, they will still be able to connect it. So one doesn't depend on the other, which is a great thing. And it is almost like a bulkhead architecture. So if there is a failure, you isolate the failure to certain parts of the system. You have graceful degradation, nice error messages and things like that going on. And it is actually really great in ensuring system stability and user satisfaction as such. So, well, good timing. It's actually deployed and verified. And if you go back into our while rights application, and if you go back into our write system, the screen should disappear because now we have actually connected things. Welcome, you can set up a backup location, you're authenticated, and I'm just going to put in a little pin and hit the request unicorn. Fingers crossed. Demo gods, help us please. Yay! That's the unicorn that's come to pick us up. Rocinate, our yellow unicorn, is on our way and it has arrived, and we can actually use the unicorn to go to wherever we need to go. So that brings us to the end of our little demonstration. Hope you all have found this one useful. Please stay on to our next part, which is an absolutely amazing session by John Walker, who's our Solutions Architect team lead. And he's going to kind of give you a nice little demonstration about how step functions can be hooked up to AI and ML type systems services. So if you're interested, that's really groundbreaking stuff in terms of a demonstration as such. You're gonna have so much value in that as well. So hopefully you guys enjoy the next part of our immersion day, and thank you for your time, guys. Cheers.
Hello,
Welcome back. Hopefully the demo has been really good in helping you out, and you kind of were able to follow all my stuff. I think at this point we're gonna just open it up for questions a little bit before we break. Any questions up until this point?
Yep, nothing at the moment. So if anyone's got any questions on any aspect of what they've seen so far, or any questions on serverless in general, we've got around 5 minutes just to have any Q&A here, and then as Michael says, we'll take a short 10-minute break before we go into the next section. So, yeah. Just while we're waiting for any answers. So yeah, as I say, we'll wait a few minutes, but just while we're waiting, as Mel mentioned, the next section will be on step functions and some of Amazon's AI and ML services. So we're specifically using recognition in this case. And there's a few slides that I'll go through just before we actually get into the hands-on demo, where I'll detail exactly what we're going to be using. But in general, a lot of how Amazon have rolled out a lot of the AI and ML services are generally split into sort of two camps. One of them is for people who actually want to use machine learning as a way of actually running machine learning on Amazon. So they've got their own models and they want to actually predict something and tweak the models and then figure out what the prediction would be. But there's another set of services which includes recognition, where you don't need to know the machine learning behind it, where you can give it some data and then ask it to predict something for you. So that runs based on Amazon's own services, where they've trained the models to be able to predict certain things. So one of the one that we're going to use here, recognition, is a really good example of that, where Amazon have run it on a vast scale of images and be able to identify different things in the image. And so that allows them to then provide a way for end users to get predictions on specific images that they've uploaded. So it takes away from you having to run a lot of your own models and your own training data, and actually use Amazon scale to be able to then figure out what's actually in a picture, for example. Or there's a few other services like Comprehend that will allow you to identify text. There's Polly, which is text to speech, and Alexa is obviously a massive one for that. So yeah, there's definitely a few different services there for that side of things, where you don't necessarily need to know the ins and outs of ML or AI to actually use and gain the benefits of it. But there's also a whole suite of software like SageMaker, where if you do want to go into that level, you can deploy your own models and go through all of that. So
yeah,
just really exciting. So I think what we'll do at the moment, I'm not really seeing any questions coming through. So what we'll do is we'll just have a quick 10-minute break here, and the next session will start back at 5:02. Okay.
Thanks, guys. We will pause it for now, and we will be back at 15:55, which is like in 10 minutes. So, and then John will start and delivering the demo. Thank you.
Yep. And if there are any questions during that 10-minute time, feel free to put them into the chat box, and we can answer them just before we're going to the next slides. Okay. Thanks, everyone.
Hello all, and we are just now about to start the part 2. I will hand my presenter back to you, John.
Okay, I'll tell just now. Okay, so thanks everyone and welcome back. So we'll now proceed on to the next section, which will cover image processing using using Amazon recognition and facial detection in there. So just quickly before we start, just a bit about myself. I'm the professional services team lead at CirrusHQ, and I've got 5 AWS certificates, including the sort of main 2 professional ones, the DevOps professional and Solutions Architect professional. Also well architected proficient, so one of my roles within the professional services team is to lead the well architected bays that we do with our customers, and that helps our customers figure out where they can make improvements in their workflows on AWS, whether that's in scalability, cost, or security. I'm a technology enthusiast, really. I love all sorts of tech. I've been involved in tech pretty much all my life, and my Twitter handle's there on screen. One thing, if I do talk about technology in general, like, and as an example, last night I was live tweeting the Apple event of all the different stuff that they had announced last night. So if you want to follow me on that. So for this next part, what we're actually going to be covering is a new feature within the World Rides app to allow users to upload a photo for their profile so that the drivers can recognize that they are who they say they are when they're logging in through the app and actually getting the ride. So we're going to be using Amazon recognition to detect faces in there. We are then going to be orchestrating all of our different lambdas using step functions, and that will allow us to actually call different lambdas in different sections depending on what we need to do. We are also going to be using the AWS shell, just as Muhil did, to run some AWS CLI commands. There's not as many in the part that we're going to be doing here. I think there's maybe 1 or 2. So we'll be using that as we go along. And again, we'll be doing the hands-on demo with the full video. So in terms of what we're actually building, this is an overview of how our system is going to work. So the AWS step functions will be our controller, essentially. It will decide which of the lambdas that we're going to deploy we're actually going to be using. So for example, when we need to do facial detection, we have a lambda that does that. So the step functions will call that lambda, and then that lambda will call the recognition service. When we want to actually store our thumbnails, we'll generate that using another lambda, and then we'll store the result in S3. And we'll also put some data into dynamodb, which we'll go through in the video of exactly what we're going to be storing. It's all about keeping track of what's been uploaded and which user has a profile. So as I say, step functions is a way for us to actually decide which lambda is going to be called in which order. So the feature, as I mentioned, we're going to be doing is for people to upload a selfie. Allows then, when they're actually being picked up, it is the person that that actually requested the ride. It also allows us to have one particular selfie for each user. So what we may have in the future, for example, is say you have a new sign-up bonus and you want to ensure that you get only individual users. So if you have an image upload, you can do facial detection and duplication to say, actually someone's already uploaded that selfie and it's user A, so we'll deny user B from using that exact same photo or the same photo of the same person. So it allows us to stop abuse of people signing up for a new account every time they want to get a discount. So this is an example of what we're going to be building. So the way step functions works is as a state machine. So when the step functions are called, we go through this process at the start, and then the first thing that we'll call is our face detection routine. And then depending on whether that's actually successful or not, we'll go then to our check face duplicate, or we'll go directly to our photo does not meet requirement. Each of these Lambdas will be explained what they do in the actual demo, but each of these is a different step within our microservices, our microservice that we're doing here. So this feature itself is one microservice essentially, but it has 6 or 7 different steps depending on what you're actually going to be doing. So there are different ways that you can use these step functions. So the one we most commonly use is a success or failure. So we'll have 2 routes out of that depending on whether the Lambda was successful or not. There are a choice one, so you can actually say, depending on what comes out, if the result comes out as A, then go down here, that sort of thing. We can also use error catching, so that if any one of the Lambdas fails, we can go directly to our function that deals with the error sets. So in this case, we're going to be using a Lambda called photo does not meet requirement. That will allow us to notify the user that there's something wrong. In this demo, actually just outputs to the logs, but we could use that for a notification function that would actually then display on the user's interface. We can also use parallel states. So if we want multiple things to happen at the same time, we can set up a parallel state so that each one of the functions are called at the same time, and then we wait for them all to complete before moving on to the next step. And we do have an example of that here, where we have add faced index and thumbnail running at the same time. Then we can also use what comes out of a Lambda and decide what we're going to do based on that, or we can use that Lambda to pass on more information to the next step. So say, for example, when we do check face duplicate, if something came out of that Lambda that had an ID, we could then pass that to the next step and then use that as details going all the way through. So in terms of the way modern apps are normally set up, so when you go serverless and you start using microservices, what you'll start to find is that each of those microservices can call each other. So as Muhil mentioned earlier, an event that triggers a Lambda or triggers something in the microservices could come from anywhere. It could come from CloudWatch, it could come from an API gateway, which it is in our case, but also you can have Lambdas call each other. So one Lambda might then trigger another, that then triggers another, and that one talks to a database. So this does introduce complexity, so you need to try and figure out where everything is going to be and what can call each other. And that's where step functions can come in. It's actually really useful for having that process flow to say, okay, we want this to happen in a certain order. So when this event comes in, we want to call this Lambda. And then based on what happens there, we want to call the next Lambda. So that's where all these different choices come in. So in this case, we have an SQSQ that triggers a Lambda that then can trigger a whole bunch of other Lambdas, write to a database, go out to an on-premise server, but then update the queue at the end. So you can see it coming back into the SQSQ. So this is where you start to see the complexity of microservices, but also the flexibility. You can actually have multiple different things happening at the same time based on a source event, and step functions are really useful for that. So in terms of using step functions, there are a number of reasons that you might want to actually use it. So sequencing functions allows you to decide that you want to run multiple Lambdas in an order, or depending on where they come in and what the outputs are. You may want to decide which Lambda you're going to call based on what's actually come in. So you may have an event, say, that comes from CloudWatch, and depending on the actual details of what triggered that event, you may want to call different Lambdas. So say, for example, you have an event that you may find something in the log. So say you've got 400 errors in a log and 500 errors. You may want to have different Lambdas or different ways of calling those Lambdas to deal with how you want to notify people about those events. You can run functions in parallel, as I've already mentioned. You can also actually set up retry functions so that if the Lambda fails for whatever reason, or if it times out after the 15 minutes, then you can actually set it to retry maybe once or twice. So it may be that you're say for example, if you're integrated into a third-party service and you know that every now and then the service doesn't respond, if you can capture that in the Lambda, then you can set a retry so that it will try the request again. And that way you don't have to have the full event start. So if your user submits a request and the first time through the third party fails, you can then retry it and then still get a success back to your user. You can also use try catch finally, which is for error handling. So you can get it to try call a Lambda, catch any errors, deal with those errors, whether that's writing out to the logs or going to another Lambda function. And then you can have a finally step so that if it falls through, then you've got something that you can actually execute all of the time within that try catch code. And you can also actually use step functions to run code for hours based on the to essentially bypass the limitation within Lambda. So what you can actually do is set up different things where, say for example, you want to run code on an EC2 instance, but everything else around that is Lambda functions. So you could have a step within your step functions that calls out to create an EC2 instance, and then use that to actually, say for example, import data into a database. So if you've got a large CSV file that you want to do an import on, spin that up on an EC2 instance, import the data, and then get that to come back to your step function, and then go through your Lambdas once that's completed. So there are a lot of ways that you can use step functions to control what's actually being run and when it runs. So just to give you a quick overview of step functions, we'll be going through this step by step in the actual demo, but the actual definition of a step function is done in JSON, but every time you update it in the console, you'll get a visualization of the actual flow. So the JSON itself is relatively straightforward, and one of the things we'll be doing in the demo is actually going through step by step how to add new functions and how to add the choice functionality, the parallel functionality. Then once you've got all that set up and everything looks okay, you can actually monitor the execution through the console. So in this example, you can see where this is green, this is a path through your execution that it's followed. And you can see where things have been successful, where they've failed. And you can click on the input and output and see what went into that function and what came out of it. So you can actually trace through how your step function is actually working. So in terms of the actual JSON, this is a very simple example of what the JSON will look like. And I'll not go through this in detail because the video will go through each step, but this allows you to set up a particular state within your step functions. And in this case, it's a task that is going to call Lambda. So this would be a one-step state function, and that would be all you need to call a Lambda on its own. You can then further expand that to have different steps, different choices depending on the Lambda output. So in terms of the different types of things that you can do with step functions, so you can have a task, which is a single unit of work. So in our case, it will be calling a Lambda. The choice will be whether you want to call one Lambda or another, or which step you want to go to next. And you can add in logic there based on the output of a previous step or the output of how it was called, also the input of how the step function was called. Parallel, as I mentioned, is where you want to do multiple tasks at the same time. The wait state type is actually allows you to wait for a specific amount of time. So say, for example, with the database load, you know, if you're loading into a database, there may be an optimization function that runs in the background and you know it takes half an hour. So you can build in that delay into your step functions. So again, it allows you that control to wait for things to happen so you can go into the next step. The failure and succeed here is where a step that you've called, whether that's a Lambda or something else, if it fails, then it can stop the entire execution and mark it as failed. And you can actually stop the entire execution and mark it as succeed without having to go through the full flow. So if there's one part of your flow where you know that if you get a specific value, there's no point in continuing, then you can fail the entire thing at that point. and not have to go through all the rest of the steps. And conversely, you can succeed as well. So if you know that there's 3 or 4 Lambdas that you've got in the rest of your pipeline that you don't need to run, if something happens, then you can use this state to do that. And pass is just a way of taking the output of one task and passing it through to another. So it allows you to pass between different states within your flow. So, excuse me. So in terms of the different ways that you can use step functions, the majority of the tasks that we're going to be looking at here are requests. So we are actually going to be invoking a particular system. So in this case, we're always going to be using Lambda. So what we would do is send a request to Lambda, it would run, and then it would respond back to you, and then you go into the next step. But you can also actually set up polling requests, so using workers to actually set up something running in the background, and every now and then the state machine will ask the service that you've set up, are you finished yet? And if it doesn't get a response or the answer is I'm not finished, then it will wait again and send another request. So how you set this up, most of the internal resources that you're going to be using within Amazon, like Lambda and SQS, etc., all of those will be requests. But if you've got something custom that you're running on EC2 or containers, then you may want to set up a long poll so that your step function will wait for that to finish before it actually goes on to the next step, or whatever your logic is set up there. You can actually set up the long polls. The state machines themselves can actually wait for quite a long time. I believe it's up to a year for something to complete, but obviously that's an extreme case. In most cases, you might just wait for how long the task is going to be. So again, with the database load, it may be half an hour. So it would just poll, say, like every 5 minutes and wait to see if it's actually completed or not. Okay, backwards up. So the next couple of slides are just give you an example of what you can do with the input and output. So in this example, we've got a state input. So say, for example, we are going to be using our face detection function. What would happen is the state would start, you would get some details from the passed in service, so whether that's the API gateway or an event. You can then call an AWS service, so you may call a Lambda function. That will bring a result path and an output path back, and then you can pass details onto the next section. But there are other things you can do within the task if you want to manipulate the data in any way. So for example, you can use result path to replace what was input with something that came out of the function. So for example, in this one, if you call the state with these details here, calls the Lambda returns with hello AWS step functions, and then that becomes your output for the next step. So you can use that to pass on messages from the output of your task. You can also use that result to actually update just one of the input values. So in this case, we have comment details and who. We've called the Lambda, and then the Lambda's responded with some text, and we update the comment with the output of the Lambda. So the next step in our step function now has that comment from the first Lambda that was called. And now we're on to actually doing the demo. So as before, there's a image processing workshop, and what I'll do is I'll put this into the chat. So hopefully you should all have received that link. And one thing I will say just with this video, there is a bit at the start about setting up the Cloud9 IDE, just as Mehul had done before, and as we did in the hands-on. You don't need to do that again. It's just there if it's not already set up for you. So during that process, if everything's still working for you, you don't need to go through that again. So we'll just start the video just now. Hi there, and welcome to our second serverless demo. The purpose of this demo is to build on our earlier demo where we built an app for users to hail taxis and allow users to upload a selfie to that for use as a profile picture, but also for security so that the drivers know that the user is who they say they are. Now, when we're building out this function, there will be a number of challenges. So what we want to make sure is that the user, when they upload the image, is actually uploading a picture that has their face in it, and that they're not wearing sunglasses or otherwise obscured. We also want to make sure that the user isn't uploading multiple pictures. So one example we may have is that we may do a promotion. So if you sign up for an account, you get a free ride, for example. Now, if users were to upload their picture multiple times, then we want to be able to detect that. So this demo will use the Amazon recognition tool. So it will allow us to take in the photos that the users have uploaded, process them, make sure that we actually have a user's face in there, and then we'll go through and deduplicate and make sure that the user hasn't uploaded the same image multiple times, just to ensure that we don't have multiple accounts there. We'll also make sure that the user actually has uploaded a picture that contains their face and not just uploaded a random picture. So to do that, we're going to be using a number of Amazon services. The initial point will be the upload of the image. These images will come from S3. So we'll have a bucket with a number of images stored in it that we'll then be processing. To do that processing, we'll be utilizing Lambda functions. So we'll have Lambda functions for calling recognition, for detecting faces, doing the deduplication, but also we'll have one for storing thumbnails and metadata. Now, one of the challenges with the Lambda there is that we have multiple functions that we want to call in a specific order. So to enable us to do that orchestration, we'll be using AWS step functions, where one process will flow into another depending on the output. So if we get a successful process in one, we'll go down one route, and if it's a failed process, we'll go down a different route. That will allow us to control the flow of what happens when a user uploads an image through to the point where we have a success on this. So now, all of the links for this lab are on the link that you've been provided in the chat earlier on. It's also on the presentation. So if you are following along, then if you go to the imageprocessing.serverlessworkshops.io, there are a few things here that we will need, such as the cloud formation for setting up the Lambdas and a few other bits and pieces that we'll use as we go along. So in the initial steps, by now you should be logged into the AWS event engine. So that will allow you to have an AWS account that we can use for setting up this process and going through all the different steps that we need. Now, so I won't go over that section here because that should be set up for you. Now, the region we are using is US East 1 in Northern Virginia. The reason for that is that the CloudFormation that we're using has a couple of references to AWS buckets that are in US East 1. That this function can be used in any region. So when you go away and if you're building your own Lambdas and using your own step functions, you can use the region closest to you. I would normally use Ireland EUS 1. But as I mentioned, there are a couple of buckets in here that are specific to US East 1, so that's the reason we're using that one. So on the region selections section, if we log into the console, the drop down here has all the different AWS regions, and for this demo we want to stay on US East 1. Now, there are a couple of other steps here for setting up AWS Cloud 9. Now, we are using Cloud 9 mainly here as a text editor. However, Cloud 9 can do a number of different functions. You can use it for full environment coding. You can upload to GitHub. You can run CLI commands. We are mainly using it in this process for constructing a JSON file
that we're then going to use for step functions. So in the first step, we need to create our Cloud9 environment. So we're going to name this the image processing development. So just copy this over here. And just for the purposes of this demo, just leave the description the same. So there are a few settings we need to set up here. This will determine what your development environment is going to be. If you need different access or more processing power, you can change some of the options here. But for our purposes, we only just need a small T2 micro. So 1 gig of RAM is fine for what we're going to be doing here. So we're going to create the EC2 instance with direct access and just all the defaults here. So T2 micro, running Amazon Linux 2, and shut down after 30 minutes. And what we'll do is add a tag here. And this will, just in general, it's a good idea to add a tag in to most of your resources. Allows you to later identify them, but also for cost optimization functions and cost allocation. So if you've got everything in your account tagged, you can see which project's taking up the most resources and which ones you need to take a look at. So if we do the next step here. So this will just give us a review page here, and it will allow us to then create an environment. So the Cloud9 part will take a few minutes to set up. So just while that's getting set up, I'll just explain a bit about what Cloud9 is. It's a fully featured cloud IDE. So it's an integrated development environment that allows you to write code and interact with other AWS services. And it's all running on a container instance that Amazon are currently setting up. And it allows you to keep all of your code integrated in one place, and allows you to not have to worry about which machine your development environment is running on. So once this is set up, you can connect to it from any browser. It allows you to have all the different features of Cloud9, such as connecting to different areas within AWS, running the CLI commands just without having to configure a lot of the different keys, etc. So it's a really useful way of working within AWS from a development point of view. So in this demo, we're not going to go through all the features of Cloud9. As I mentioned, we're just mainly using it as a text editor for creating our JSON. So now that that's set up, we can actually move over to the implementation section. Okay, so I'll quickly go over just exactly what we're going to be building here. The architecture that we're going to be building, as I mentioned, is to be able to take in a photo and process it. So we're going to be using step functions here to orchestrate that. And we will have a Lambda that will do facial detection, facial validation, such as whether there is actually an image in place, and index that face into our recognition, so that when we want to go and see if that image is already there, it's part of our recognition data set. We'll also generate a thumbnail. So we'll make sure that we have at least a certain size of image, and if it's bigger than that, we'll scale it down, just so that it can actually appear on the application. And that way, it doesn't really matter what size of image the user uploads. And a lot of these smart format images, when people take a selfie, the actual size of the image will be really large. So we'll reduce that down using image magic. And then we'll persist the metadata from that image, such as the name and the user that it was uploaded for. And we'll utilize dynamodb for that, which is a NoSQL database that runs serverless. And it's very useful for things like this, just keeping track of files and IDs that we're currently using. So that'll be our data store at this point. So onto the actual step function itself. This will be our final version of the step function. Now, as we go through this, we will be building this up step by step so that you can see how the step function can evolve when you want to add new features or new pathways. So I'll go through this in more detail. I don't need to go through the full step-by-step just now, but it works as a flow chart. So if we have the face detection, the two arrows that are pointing out there are whether it's success or failure. So in this case, success means that we'll go to the next step of check face duplicate, and failure means we'll call the Lambda that will notify the user that the face, or the photo rather, that they've uploaded doesn't quite meet what we need. That will also happen whenever there's a duplicate in there as well. So the first step we need to do is to create a Amazon recognition collection. Now, this will actually allow us just to store all of the images that we upload to Amazon recognition in one place. So to do this, what we need to do is copy the AWS command here, and this will call the recognition CLI and create a collection of our photos. So the next step, the last parameter we need to add in here is just to put in our region, which is US East 1 in this case. Now, that's come back with a status code of 200, which has meant it's okay. And now we have a resource number for the collection that we've just created. So the next step after that is we need to launch our CloudFormation. This will actually create our S3 buckets, the Lambdas, dynamodb, and all of the different roles that we need to actually perform this function. So, as I mentioned earlier, this is only available in US East 1 at the moment due to some other buckets that are also in US East 1. So if we click on Launch Stack here, what this will do is it will use the template that Amazon have put in their own S3 bucket and use that as the basis of the template or the stack that we're going to deploy. So we'll just click Next here. So this will allow us to create all the resources for the step functions. The collection ID that we've just created there is already pre-filled in for us, so it's rider photos. The bucket that we've created will be, or the bucket that will be created rather, this is where our four images are going to be uploaded to, and they're in a folder called test images there. So as before, we'll just add a tag in. So we'll do AWS demo and click next. And in this case, when we're creating the CloudFormation, the stack will utilize a number of roles to create the objects that we're going to want it to create. So we just need to acknowledge here that those resources will be created by the stack. So this process usually takes a few minutes. Just while it's running through that, I'll show you some of the template just to take you over what we're actually going to be deploying. So there are a number of outputs we're going to get here. So these ARNs here are all of our different Lambda functions that we're going to be using. Those will be important later. So in the CloudFormation, there'll be an outputs section. So there's nothing there at the moment, but once the CloudFormation has completed, the outputs will have the Lambda ARN, the role, the bucket, and a few other things. So while we're going through this process, there are a number of places we need to put those values in into the step function so that it knows when you run the step function, it knows which Lambda to go and run. So once the template has completed, we'll take those values from the output of the CloudFormation stack. So what this is actually going to be deploying is a number of Lambdas. There'll be a Lambda layer for ImageMagick, which is a third-party, well, it's an open source tool, but it's a third-party layer, in this case, that has been prepared for use in Lambda. So what that means is that when you deploy a layer, the Lambda that includes that layer will just be able to access the function that you've deployed in that layer as if it had been installed on the machine that it's running on. So in this case, we'll be able to import from ImageMagick and use the functions there. So there are a few other Lambdas here. So creating the S3 bucket, copying the objects from there, detecting the faces in an image, and a few other ones like searching for a face. So we'll go through those lambdas as we use them, and I'm not going to go into full detail of what each lambda does line by line, but I'll give you a broad overview of what its aims are, and the main lines, such as when it's calling recognition or when it's using the image magic function. So those that has now completed. So in the outputs here, as I mentioned, we have the ARNs for the Lambda functions. We have our dynamodb table. We have our S3 bucket, which has our 4 uploaded photos at the moment, which come with this template, but we can also upload our own photos to them. And we have a role for the state machine, which is our step function that we're going to be using. And then a function to create the thumbnails and the S3 bucket for where the thumbnails are going to be stored. Now that we've created our CloudFormation function, the next process we need to go through is to create our step functions, which will allow us to orchestrate the lambdas that we've just created within CloudFormation. Now, the initial step that we're going to be doing is a simplified version of what we're going to end up with, and we'll go through step by step, adding extra lines to the step functions to do more functionality. Our initial state of this is going to be calling your face detection function to make sure that there is actually a face in the image. And if there is, we'll end there just now. And if there isn't, then we'll call a function that will, at the moment, we'll just output that there is no face there, or it doesn't meet our requirements. But in the future, that function can then be used for notifying the user and getting them to upload a new photo. So the first step we need to do is in our IDE in Cloud9, we need to create a new file, which is called Rider Photo State Machine. So if we just copy that, and to create a new file in this folder, we right click and go to new file and paste in the name there. So that will be our JSON that controls our step functions. So in this file, our initial state is going to be this section here. So the code here for the JSON, you can actually just copy to the clipboard using this icon. And if we go over to our IDE, we should then be able to edit that and enter our JSON. So we saved that there just now. So in the IDE at the moment, as I mentioned, we're only going to be using this for its text processing functionality just now, but we can use this for other functions such as actually running lambdas directly from the CLI here, like we did with the recognition. Now, this section of the JSON is the 2 states that we're going to have. So if we go through this just line by line, the comment here is just explaining what we're going to be doing. This startup function tells it which of the different states we want to go to first. Then within there, we've mentioned that we're going to be using face detection. So first task here is to set up a face detection state, and it's a type of task, which means we're going to be calling a Lambda function. This resource here is going to be the ARN of the Lambda function we're going to be calling. So we'll replace that in a second. Then the rest of the process here just allow you to take values that come out of the function you've just called and do different things with them. So in this case, we're going to have the face details come out of the Lambda function so we can use it later on. And the end true here just means that if this process is successful, we want to just go to the end. In the next section, we'll be adding in a next step here. So that tells the function where to go if it's successful. And this catch is where we deal with any errors. So if we got an error that came out of our Lambda function that mentions that the face doesn't meet the requirements, then we want to go to we want to take the error info out of there and go to the next step of photo does not meet requirement. So as you can see there, when the step function runs, if it's successful, we'll currently just go to the end. So that's this end true. And if we catch an error, then our next step will be does not meet requirement. And this next section will set up that does not meet requirement step. There's also a task and there's also a Lambda function. But in this case, we don't need to pass it any parameters. We're just calling the function, so we don't need to set any result path or have anything going into it. So the next step we need to do here, there are two sections we need to replace. This function ARN for the face detection, and then one for the notification. So to get that information, we go to CloudFormation. So the first one we need is our face detection. So that will be this one here. So if we copy that, and then we can replace the resource there. Now, when you copy that in, one thing to watch out for is you may have accidentally copied an extra few spaces at the end. You need to make sure that it's fully within the double quotes. There's no spaces on there. And the next one we need is the does not meet requirement. So that will be our notification placeholder. So it's called that because that function will be used for notifications if we further develop this. But at the moment, all it does is tell you that there's an issue in the logs. So that will be the Lambda we need to replace into here. So, okay, so now that we've got all that, the next step is to actually create the state machine. So if we go into AWS step functions, let me just get this. Okay, so in the step functions page, one thing to just double check is that you are still in the correct region, so make sure you've not switched out to any other one. So we want to run this in US East 1, which is North Virginia. So to create the step functions, if you click on the three lines at the left hand side, and then click on state machines, this will allow us to create a new state machine. Now, the simplest way to do this for our demo is just to author it with a code snippet. We are actually going to change the code snippet in here, but it allows us to just have the default set up. So this section here is what we're going to be replacing with our code that we've saved in Cloud9. So if we just copy this in the state machine, add that in, you'll see that it's generated the graph at the side here. So we start, run the face detection Lambda, then if we error, we go to doesn't meet requirement, and then end. So we have everything set up here. So now if we click next, what we want to do is just change the name of this. So let me just check the, what do you call it, rider photo processing. Now, to ensure we're using the right permissions, the CloudFormation has already set up a role for us. So we want to choose an existing role here and use the well-dried step module resources. We don't want to turn logging or tracing on, although they are really useful features in the real world. So the logging will allow you to actually have logs from the state machine itself from step functions, and the extra tracing will allow you to have an ID that follows your functions all the way through and allow you to gather that in one screen so that you can see where you might be having issues or where you might be failing over and above what the step functions will tell you. So that's a really useful feature, but it's not something we're going to go into here. So at the moment, I'm just going to add in a purpose as before for AG demo, and we'll create a statement. So just need to make sure that you don't have a space at the end there. And that should be that created. So to demonstrate that this actually works, what we want to do is run an execution. Now, to actually run this, what you need to have these three parameters that we've got in the documentation here. So the three things that we need to pass in for our function to work are a user ID, the bucket that we are actually storing the images in, and then the name of the actual image that we're going to pass in. So our bucket is in the CloudFormation again. So this riders photo S3 bucket. So if we copy this and just change use the bucket here. Now, what this will do is it will execute the functions, take the file that we've called onehappyface.jpg and have that as user ID A. And just before I run that, actually, what I'll do is just demonstrate what that image actually shows. So if we open up S3, our CloudFormation has created a bucket for us with these 4 images in it. So if we scroll down and just look for the one which is created, so it's our step modules, resources, rider functions. It's also got an ID on the end of it that comes from the CloudFormation stack. The reason for that is it allows you to create buckets with the same overall name, but with an appended ID on it that's unique to that stack or unique to that run. And that way you can use the same CloudFormation multiple times and you won't get conflicts of having to use the same bucket. So look in here, the bucket that's been created, there are 4 JPEGs that have been uploaded for each of our different types of things we're going to be checking. And the first one we're going to use in this is this happy face. So if we open that, you'll see it's in this case, a gel with who's smiling. So if we run through our step functions with that, we do start execution. What you'll see is at the moment, it's currently running the face detection. So if I click on that, you'll see that it's in progress. So it's currently actually running the Lambda. And now that it's turned green, it's been successful. So if we go to input, this is what we've just passed in. So we've got the user ID and the key. And then the output of that, actually click on it again, sometimes it takes a second to upload. So what that's outputted is the details from recognition. So there are a few different areas here. It's the ones that we're going to be using are the confidence, which I'll come on to in a second, but the details that come out of recognition can be useful for a few different things. So we have the bounding box here. This is just the details of the image. We have a guess at the age range, so 5 to 15 in this case. And then we have a few confidence intervals where the Amazon recognition is to say that is the person in the image smiling? In this case, yes, they are, and we have a 99% confidence interval that they're smiling. Are they wearing eyeglasses? In this case, no. Do they have sunglasses on? Again, no. It has a guess at the gender, in this case female, and it's 99% confident in that. Whether they have a beard, a mustache, whether their eyes are open. And now in this case, you can see here that it has brought back that it thinks the person's eyes are open, but it's only a 68% confidence. And in this case, it's because the user's slightly side on, so that it can't see both of their eyes. 99% whether the mouth is open. And we also have these emotions here where it's trying to decide whether the person's happy, surprised, sad, etc. So again, 99% happy because they're smiling, not surprised, sad, showing no fear, calm, angry, etc. And then there are a few other sections here about the quality of the image and the actual pose of the person in the image. So the last one here is confidence. This is the confidence that there is actually a face in this image. Because the function that we've called within recognition is for facial recognition. So this is the one it's going to use to make sure that it is actually calling something with, or the image does contain a face. So that output there is our main output that we're looking for the next few steps. So in this case, if we uploaded something without a person's face in it, this confidence would be quite low. And then in that case, we would go to the photo does not meet requirement section because we would be outputting a false from our Lambda. So step function would know to go to the route that doesn't meet the criteria. Okay, now that we have our recognition function up and running and it can detect faces, the next thing we need to do is make sure that the user hasn't uploaded the same image. So if we look at the step functions here, we want to add in another step called check face duplicate. Now that will call a Lambda and it will take the image that's been uploaded and check it against the images that are already in our collection that we created earlier on. And if it does find something in there, it'll return a true value. and then it will go to our does not meet requirements function. That means we can use the same function for notifications, and in this case we are saying that the image that you uploaded is already there, or the person in that image is already there. So to do that, what we need to do is add in a new section to our state machine JSON. So go ahead and copy this. This is where the ID will come in handy. So what we need to do is add in after the photo does not meet requirement state. So in here, if we just paste that in. Now, while we've pasted that in, it will work like this. Just to make this clearer where everything stops, I'm just going to tab this in so everything lines up. So there are a few things we need to do here to make this work. So again, we have a resource that we need to change. So we need the actual face search function, and we need to change one of the parameters in the previous step. So go to cloud formation again and grab our ARN for our face search function. If we add this in, and again, just check for spaces at the end. Now, that step in itself will work, but what we need to do is make the step function, after it comes into face detection, go to our new step rather than directly to photo does not meet requirement. So to do that, what we need to do is, in the face detection section, we remove the end as true and add in our new step. So just copy that there. So in face detection, normally this would just go directly to the end, but we want to replace that. Start that. So the next step for face detection, if it works, then we go to check face duplicate. And if that fails, it will go to does not meet requirements. And also our face detection, if it fails, then it will go to does not meet requirements. So now that we have all that, copy that. In the state machine, if we just go back to our step functions, if we go to edit and paste in the JSON here, you'll see that it now matches the diagram and the documentation. It will come into face detection first, then if that's okay, it will go to check face duplicate, and if it's okay, it will go to end. And if either of those error, they'll go to does not meet requirement. So we'll save that. Now, there will be a warning here that it might affect resources that are already there, but this is just to ensure that you're not adding anything that the role doesn't have access to. In our case, the role has access to everything it needs to, but there is a possibility here you may have added in a new task that the role isn't quite able to handle. So this is just a warning just to make sure that you know that your role has full access. So now that that's been updated, we can go back to the main page and start a new execution. Now, in this case, what we want to do is essentially upload the same photo again. So copy this. Again, we need to add in the bucket name here. So again, we're looking for the Rider Photos S3 bucket name. Copy that. So again, in this one, we are uploading the same user, the same image, and from the same bucket. So what we expect to happen here is that to recognize that it's the same person and go to our new, or it'll recognize the face detection first, go to our new duplication function, recognize that it's the same person, and then it will fail. So if we run that, then you can see that it's running the face detection, so it's calling recognition and making sure that it's actually got a face in there, and that's completed. Okay, so now that we've run the execution, you'll see that the two steps have run here correctly, and what we'd normally expect and how we've set this up is that when the face duplicate is detected, it will go to not meet requirement. But there's an extra step we need to do here within recognition just to index the faces that we're getting. So that'll be our next step. So the check face duplicate will succeed all the time at the moment. we just go to the next step. So what we need to do here is add the face that we've just detected into our indexing function, which will be backed by dynamodb. And while we're doing that, we may as well also create our thumbnail. So this step will allow you to see how you do parallel processing. This is where you want the output of one step to run in both of the next steps and then go on from there. Then the way that we do that is within one section of the step function, you have an overall task, and then there'll be tasks within that we want to run in parallel. So if we have a look at the code here, so I'm just going to copy this just now, and what we want to do is add this after our check face duplicate function. So go back into Cloud9 and scroll down at the bottom. What we want to do is add it after this section here. And again, I'm just going to highlight this and tab it in just so it's all lining up. Now, if you have a look here, we are creating a parallel section, and this means that we can run multiple tasks at the same time. And these two separate sections are two different tasks. So first one here is we add the face to our index, which will add the IDs and everything to dynamodb. But also at the same time, we want to run our thumbnail function, which will create a thumbnail from ImageMagick. So as before, we just need to add in our resource ARNs for our Lambda functions. So first one is our index face function. And copy that over. And second one is our thumbnail. So that will be this section here. Okay, so now we have the two functions in there that will run. And as before, we need to make sure that the output of the check face duplicate doesn't just go straight to the end. We actually want it to go to our next step of parallel processing. So if we grab this. So we want to replace the end true of our check face duplicate. So that was the last function that we had. Normally it would go straight to the end, or previously it would go straight to the end, but we would now want it to go to our parallel processing step. We change that over there. And that will then run each of the tasks. So we save that. And as before, we want to update our step function. So if we go back to the new page and click edit and replace the code in here, you'll see that the graph is now updated to what we expect it to. So when it comes in, it will run the face detection function. If there's a face in there, then it will run a face duplicate function. And once this is run through the indexing function, the next time it comes in, that face will be there and in our database. So when we run this the first time with the same face, it will probably complete again. But just because the index isn't updated, then we'll add it to the index and create a thumbnail with our new step. So if we go ahead and save this, save it up top. And again, just make sure we've got the correct roles. Now, what we want to do is start another execution. And again, in this case, it's exactly the same. We're going to be running the image A again. So copy and paste the JSON as our test input and grab the rider photos bucket and put that into our test. So we add that in here. So we're going to update the same photo. Now, if we run this, as I mentioned, what we're doing just now is we're checking the face detection. Then once that's actually run, so I say each of the sections you can actually make it so that it's, when you click on it, you'll get the details, what was input and what was output from that function. So in this case, we detected a face, so we succeeded. We checked for a duplicate, but there was none. So as I mentioned before, the one we've just uploaded, user A, wasn't in the index because of this was a new step. Any other run through this, that user will now be there. So we then ran our add face to index, and that essentially gave us our details, so external image ID, and then we've created an image ID in the dynamodb. And the thumbnail has been created in our S3 bucket for thumbnail, so I'll quickly show that. So we have a separate bucket that the CloudFormation has created that just has the thumbnails. So it saved a file in there called freesized1 and then the name of the file. And if we go into that, you'll see it's created a much more reasonable size image for our application. So what we can do is, just to demonstrate that, we can have a new execution and upload the same file again. And what we'd expect this time is that it will see the images there and it'll come back as a failure, and yep, it's now calling the photo does not meet requirement function. So that way, it's now that the ID of that image is in our dynamodb, when it does that lookup and matches the image to ones that are already in our collection, but have also been added to our index so that we know what the IDs are, it will now recognize that there is a duplicate there. Okay. Now, the next section we just need to do here is just to make sure that we are storing the details of the user. So the idea here is that we want to persist any metadata that accompanies the photo. So like the name of the photo, the name of the user, and just make sure we're storing that so that it can be used later on in the actual profile. So everything we've done to this point is storing the image and storing the ID of who that is an image of, but we need the file details as well. So this last step here, we just need to add in the persist metadata. And again, we'll go back to our Cloud9 and add it after the parallel processing step. And just tab that in. Now, we just need our ERN from the CloudFormation. So we have our persist metadata function and replace that. Now, what we want to do is make sure that after our parallel processing, then we run our persist metadata function so that we end up with a step function that looks like this. So we want to add in this step. Now, one thing to watch out for here, in the parallel processing, this section here where it says entrue, and the outer part of the function is what we want to change. There are two other entries in here for each of the individual functions, but we don't want to change those, because that will, if we changed a next step in there, then it would be within our parallel processing step. So looking at the graph, this would add another line from here to the end, and we don't want that. We want it to go after the parallel processing step. So what we need to do is just change that over to make our next step the persist metadata. So again, it's the one at the end of the parallel processing function. And that will then call our persist metadata function. And as before, we want to edit our step function and paste our JSON in. So now, after this, where the dotted line in here is our parallel processing function. After that section, it will run the persist metadata, and that will just store more information about the image that's been uploaded. So if we just save that, again, save anyway. Now, we can actually start an execution directly in here. I've been going back a page just to the overall page, but you can actually do it directly from this section. So just grab the JSON that we want to run. So again, we're going to run with the same image. Once we've done this, we'll run through some of the other images just to show what they do. Again, we'll put in our riders photo bucket. And start the execution. Okay. Now, what may happen here is we may actually, because we've uploaded another user, it's going to not meet the requirements. So there are, if we decide that we want to change the collection, you can actually clear that out using a CLI command. There's, I believe it was in the parallel processing step. Yeah, so you can actually delete all the faces. So, or you can go through each individual face and delete them. But what we'll do is we'll just upload. In fact, just to show that step, I'll copy this and just get a list of the faces. So in the CLI, so when we paste this in, because it's a multi-line comment we've just copied, you just need to make sure that there are backslashes at the end of it. Now, our collection ID is rider photos there, so we're passing in collection dash ID, and we want to do US East 1. So if I just open this up a second. So what that's done is it listed all of the faces that we're currently storing in our recognition collection. And you can see this was the ID that we generated earlier on, and we have an external ID. So to actually delete that one so that we can go through the whole process again and add our metadata in, what we can do is copy this. So we want to copy the first section of this just up to the face IDs, and then we want to add in this face ID. And then the last section, we just need to make sure that we actually have our dash region in there as well. So we do dash region US East 1. Okay. So that's now deleted the ID that we passed in. So if we just hit up and just run the list faces again, there are now no faces in the collection. So when we run the step function again, it'll go through and store the ID, store the image, but also now store some more metadata. So if we do a new execution again, same user ID, same bucket, and same image that we're going to upload. Let me start that. This time when we check for duplicates, it won't find anything, so we've just deleted it. And it should go through to our parallel processing and metadata. So it's added the pasted index, created a thumbnail, and persisted the metadata that we've got in there. So that's just as adding a bit more detail about the image. So what we'll do is the next section will be to actually just go through the lambdas just to show exactly what they're doing, and we'll show exactly what the metadata function is doing there. But that's our state machine up and running. So essentially what we've done is created each step and built it up, and that allows us to test each section as working as it should be. But now that we have the full function, we can upload an image and have it detect if there's a face in there. If there is, we'll add the image to our recognition collection so that it can be checked again. We'll check if that face is already in there, and we'll store details in our database about the image itself and then the metadata. And you can continue to iterate on this. So you could add in extra functions that when you actually get a successful function, we would then put it into the application and store that as a profile image, or there are things that you can do with the image itself. So just to show you what else recognition is capable of, there are 4 images that we had uploaded. So if we just go to our SD bucket, we'll show you those. So the right as follows. So the next one we want to do is this image of someone wearing sunglasses. So what we'll do is just show you the image. So it's a woman wearing sunglasses, which isn't really great for a profile picture because it doesn't allow you to identify them. So we just take the name of this. And one thing I will just say is at the moment when we're doing an execution, we are uploading this test function essentially, but this can be hooked into like an S3 bucket and have it run on every file that comes up. So you could have a process where the user uploads their image, that image is then stored in an S3 bucket, and you use the event that has occurred when the S3 bucket was updated, and that file was then passed into the step function. So all of this would be automated, but for this process here, we're just running through step by step of what would happen running through the step functions. So if we just change this, and so our key now is the sunglasses face. We also want to just change the user ID because we are doing this from a point of view if it's a different user. And if we start the execution there. So if we scroll down, so it's already actually run through. So the first thing it's actually done is during the face detection, it's actually detected that the person was actually wearing sunglasses. So you can see here that the function has caught an error, and you can see the reason is that the person's wearing sunglasses, which is not suitable for our purposes because the profile is there for identification. If you're wearing sunglasses, the driver won't know that you are the right person. So it's went directly to our not meet requirements function. And similarly, if we check the third one, sorry, it's name of it's slightly different. It's 3 multiple faces. So copy that and just quickly show you the picture that we're going to upload. So it's a group of 3 people, which again is not a great profile picture for identification purposes. So if we change the key here to use that file, so I still have the previous one in it. Just grab this. And again, we'll just go with the same user because at the moment, because the photo has been rejected, this user doesn't have a picture yet. So again, what we should expect the status here to be caught error, and just wait a few seconds, then yep, it's now updated. So it's caught the error, and the reason is that it's actually detected 3 people in the photo. And when we go to the Lambdas, I'll show you why that's able to come through like that. So recognition itself isn't the section that's actually rejecting the picture because there's 3 users in it. That's something our Lambda that we've uploaded is doing. Because recognition, you may want to detect 3 people in the photo and actually use that for a reason, but in our case, we only want 1 person in the photo. And just before we do that, we'll upload the last one. And again, I'll quickly show you that. So this is a photo of a city. I was going to say it's New York, but I'm not 100% sure on that. So we'll upload this one to a new execution. Give a new file name. And that will do it. It's already run through and it's not detected any faces in the picture this time. So that in essence is our full end-to-end functionality. So I'll go through a few of the extra sections in a bit more detail, but this is our feature up and running essentially. So we're detecting the faces, making sure that our write-through isn't storing information about it. In the future, we could then go on and use that information for other things. But just to give you an idea of what we're doing here, if we're going to the Lambdas. Okay, so if we look for face. So the first one is our face detection function. Now, we're not going to go through the full section of Lambda setup here, or the full details of the actual code, because this isn't designed as a how to write Lambdas lab. It's essentially just using these Lambdas to call recognition, but I will go through a few excerpts from it. So the main one here I'm going to mention here is that we're actually creating a recognition constant that we're calling. So this function is in Node.js, just to make you aware of that. So we have a handler to our recognition service. There's a few sections here that will read the event, get the details of the S3 bucket, but the main one we're going to be looking at here is this detect faces function. So recognition has a number of different functionalities, but the one that we're interested in is whether there are faces in there. Now, when we call that with the image that we've just uploaded, if we check this face details and is not equal to 1, then we can output an error saying detected X faces in the photo, and that will cover us for 0 or more than 1. So we only want one photo in one face in the photo. So anything else there, we fail on that one. And in this case, we're using the sunglasses feature as well to fail if the person's wearing sunglasses. So once we have that, then we can return the details of the face. So in this case, it's a section called landmarks that are in there that we also want to remove that. So there are a few exceptions that we handle in here as well. Just some images are too large for recognition to deal with, or if there's a formatting issue. So in our case, we only are able to handle JPEG and PNG. So we want to return an error if that's not the case. Okay, so that was our face detection function. Now, the next section we just want to quickly look at is the face duplication function. So if we have a look at this, the face search function, this is the one that we're going to make sure that the face that's been detected in the image isn't already in our data set. So if we look at the index.js here, again, we're going to be using recognition, so we'll create a constant for that. Scroll up just so you can see this. The section here will just get the details from the bucket. We also want to make sure that when we're calling recognition, there's a couple of parameters we give it to make sure that we're not overly strict on it. So when we've detected a face and we're matching it, we want to make sure that the threshold is about 70%. So it doesn't need to be the exact same image, but if it's roughly the same person, then it'll match. Also just making sure that we're doing more than 3 matches. So the main section here is this recognition search faces by image. And what that'll do is pass in the image that we've just had, and it'll go through our recognition collection and see if that face matches anything. So if we get a match, then this face match's length will be greater than 0. So maybe 1, 2, or 3. And then we can raise an error. And that will give us a message here of the face in the picture is already in our system. So even if you upload a different image, it's the same face with a 70% confidence, then it will reject that photo as a duplicate. So if we just go back to, just quickly go back to our step functions here. So those 2 functions are kind of main 2 ones, but the next section, just going to view details, definition. So that's these 2 sections here. If we look at the add face to index next. Okay, so that'll be our resources index face function. So again, if you're starting to find the Lambda, the list of Lambda ARNs are in the CloudFormation. So index face function ARN, the full details are there, and you can paste that in. So if we have a look at this one, again, we're going to be using recognition. We get the object from an S3 bucket, and in this case, we are going to be calling our index faces function, and that will create a record within the recognition of what the faces are there. So that will allow us to just make sure that when we call the matches, it's able to give us back the IDs for the faces that we've already got. So in this case, say we uploaded the same image to user B that we'd already done in user A, then now that we've indexed it, the recognition would be able to tell us that's a face of user A, and we can use that in our error collection. Okay. And at the step functions, we want to now look at the thumbnail section. And this is where we are using image magic. So this, in the section of Lambda at the top here, one thing I just want to point out is this one has a layer, which is Image Magic version 2. So that's actually came from an AWS SD bucket, an AWS layer, and that's included in our section. So what that allows us to do then is, in this call here, we want to require this GM function, but just the image magic part of it. And as I say, we're not going to go through all of this function because there are a lot of details in here that are required for processing it. But this section here will ensure that we are creating images that are 250 by 250, or if they're smaller, then we also want to just keep the image. So if someone uploads an image that's already 200 by 200, you don't want to make it any smaller than that. So the 250 will be what we resize images to. So the main ones, again, we're getting it from S3. So the main one is this call here. So this will get the image metadata, so that will get the size, the type, etc. Then once we actually have that, we can call our resize. So we get the size that's been identified, scaling factor, again, make sure we're only resizing down to the right amount. And we call our GM function with to buffer here, and that will then actually give us the image back resized. And then we can put that into S3 here using the S3 upload section. So we've looked at the image, identified the size of it, got some metadata, resized it, and then buffered that out to a file that goes to S3. So we call the S3 upload function, and that logs it to our thumbnail bucket that was created. So the next one's after the parallel processing, we just want to persist the metadata. So if we go back here, so in our persist metadata function, this is where we are going to be calling dynamodb. So in this section here, we want to create a dynamodb connection and in the region that we are in. So the table name is passed in here, so it's part of our step functions. When we actually get that, what we do is we create an item. So we've got the user ID, the image, and the bucket we're going to be putting it in. And the output here, you'll see in the event, we have this parallel result. So that's the output of both our indexing function and our thumbnail details. So the first one will give us our index, so that will give us the ID that the indexing from recognition came back with, so like user A, etc. And then in this next section, we'll get the details of the thumbnail, so where it's uploaded and the name of the thumbnail. Then we can put that into dynamodb just by calling the .client put. So again, we're not going to go into the full detail of the Node.js here, but this will show you how using these Lambda functions we can call different AWS services. So we can start from S3, we can process things through recognition. We can also do some processing in the Lambda itself, so using image magic and resizing things, and then also using dynamodb, all serverless all the time throughout this. So end to end, we've got a fully serverless solution that allows us to detect images, resize them, etc., which should be useful for our application. And just quickly, I'll show the notification one. Again, this is just a placeholder that will output the details. So all that's actually going to be doing is, if it's called, it gets the event details from the function before it and just outputs those to our logs at the moment. And in the real application, this is where you would actually be doing notification for the customer. Okay, and one last section, I'm just going to quickly show the dynamodb, and then that should be it. So if we just go into tables, see we have our rider photos in here, and if we just look at our items, we've got our user ID, face ID from our recognition function, so that's the face that's been uploaded, the person that's in there, and then just a bucket where that's actually stored. And that's intent. So just before we finish up, the one last thing I just want to quickly demonstrate is that this isn't just set up for the demo with the faces that are in there. So if we just go to S3 just now, and within our bucket, so read the photos, what I'm going to do is I'm going to upload an image of myself just to demonstrate that this does work with other images. So if I add file, it should be on our desktop here. So just uploading the file into S3, and this is successful. So quickly show you the image just before it's uploaded. So it's an image of me taken from our website. And if we just grab the name there quickly, the file will just upload. So if we run a new execution, and we'll just grab the JSON for our execution. So we add this, and just call this user B, and grab the name again. So all I'm doing is call same function, just with a new user and the image that I've just uploaded. So just one last section, I just need the bucket source. So run the face detection, and because my picture isn't in there already, then it should complete successfully. Yes, and it's, we're looking at dynamodb, that's now in there as well. But the reason I've uploaded this is what I wanted to show you is the face detection function. Within the output at the moment, we're only really using the fact that there is a face there or how many there are. But recognition does actually return a lot more information. So as I mentioned before, we have the age range, where they're smiling. So in this case, I'm not smiling in the picture, which is true. Whether I have eyeglasses on or sunglasses, again, it's false. It's detected that I'm male. It's also detected that I do have a beard in the picture. Don't have a mustache. I think it counts the full beard as that. My eyes are open, my mouth isn't, but it's also detected that I'm 98% is sure that I'm calm in the photo rather than happy. So it's just a quick demo there, just that this isn't just on the images that have been uploaded, it also actually what's on other images, including mine. So, and I believe that's us at the end now. So I hope you've enjoyed this demo. You can see the power of the serverless applications we use. So we've used S3 for file storage, and that can also be used to trigger events. The recognition service that will allow you to detect faces and images. You can also do a lot more. The recognition is one of Amazon's powerful machine learning tools that don't require you to actually use machine learning, but allow you to gain the benefits of that. And as you can see, it can detect quite a lot of different things in the image as well. And that's just for the facial detection. There's also object detection and a few other things. And I hope you can see the use of step functions where allows you to orchestrate different lambdas and tie them together and do different things depending on whether you've got success or error. So all of these functions that are in here, the 6 of them, you just need to write those functions, but you don't necessarily need to write the control code around them. You can have step functions do that for you, just with a JSON. And okay, and that's it. So thank you very much for joining in, and we'll hand back over to the presenters. Thank you.